Hello, is I am audible to everyone?
Yeah, yeah. Yes, you can proceed, please.
Organizers, can we proceed for inaugural ceremony?
सतीश किती वेळ आहे सुरू करायला? हॅलो सतीश.
साहेब मी फोन लावला देवळानकर सरांना.
हा हा
1-2 मिनिटात बहुतेक ते जॉईन होतील. मग सुरू करू लगेच.
हो हो सर जॉईन झाले.
We have 2 minutes.
हो सर झाले जॉईन. सर झाले.
Yes, all dignitaries and participants, we have 2 minutes to start inaugural ceremony. Please be patient. Thank you.
देऊन टाकला मीटिंग चालू व्हायला टाइम.
उपाशी ठीक है दादर सर
Yes, sir.
Devlankar sir will join later. Let us start.
Okay. 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 Is I am audible? Okay, sir.
Yes, sir.
So we are starting the inaugural ceremony. So a very good morning and warm welcome to all dignitaries and participants joined over the online conference in the online platform of one-day international conference on artificial intelligence in mathematical and chemical sciences, organized by Digambara Bindu Arts, Commerce and Science College, Bhokar, Nanded, in collaboration with Swami Ramananda Tirth Marathwada University, Nanded, Maharashtra, India. Here, we are privileged to have Honorable Dr. Sailendra Devlankar Sir, Directorate of Higher Education, Government of Maharashtra, as the inaugurator of this conference. I welcome him on behalf of organizers. The chief guest of today's international conference, Honorable Dr. Manohar Chaskar Sir, Vice Chancellor, Swami Ramananda Tirth Marathwada University, Nanded, Maharashtra. The guest of honors for today's international conference, Dr. K.L. Bondar Sir, Joint Director, Higher Education, Nanded. Dr. D.D. Pawar Sir, Registrar, Swami Ramananda Tirth Marathwada University, Nanded. Dr. S.M. Jogdan Sir, Principal and Member of Council, Swami Ramananda Tirth Marathwada University, Nanded. The keynote speaker for this international event is Dr. Prasanna Kumara DC Sir, Department of Studies and Research in Mathematics, Devangiri University, Gangotri, Devangiri, Karnataka, India. We have Dr. R.S. Varun Kumar Sir, Department of Pure and Applied Mathematics, School of Mathematical Science, Tanwe University, Malaysia, as a foreign guest, and Dr. Nandakishore S. Chandan Sir, as from Organic Chemistry Fellow of University of Oxford, England, UK. As a resource person for today's conference, I also welcome the chief guest of today's conference, respected Principal Dr. Punjab Chavan Sir, Digambara Bindu College, Bhokar. The convener, Dr. S.B. Chavan, Head Department of Mathematics. Co-convener, Dr. Z.D. Kotapalle, Department of Chemistry. Coordinator, Dr. A.B. Chavan, IQAC Coordinator. Organization Secretary, S.S. Tivde, Head Department of Chemistry. Dr. M.R. Fegde, Head Department of Statistics, with the Joint Secretary P.V. Take and Treasurer O.K. Bedewar, Department of Mathematics. Here, my dear friends and all dignitaries, without taking much time, I request convener Dr. Satish Chavan to have brief introduction for the idea behind organizing this conference. So may I call upon Dr. Satish Chavan, convener, to introduce this conference.
Okay, sir. Thank you. Thank you very much. Good morning to all. I am delighted to extend warm welcome to International Conference on Artificial Intelligence in Mathematical and Chemical Science. Host of the conference, Digambara Bindu Arts, Commerce, Science College, Bhokar, in collaboration with Swami Ramanand Tirth Marathwada Vidyapit, Nanded. We are very honored today to have important guest or patron, Dr. Madhavrao Patil Kinnakar sir, President of late Digambara Bindu Smarak Samitis Bhokar and former Minister of State of Maharashtra. The inaugurator of this conference, Dr. Sailendra Devlankar sir, the Director of Higher Education, Government of Maharashtra. Our chief guest of our university, Vice Chancellor, Dr. Manohar Chaskar sir, Vice Chancellor, Swami Ramanand Tirth Marathwada Vidyapit, Nanded. Our guest of honor, Dr. K.L. Bondar sir, Joint Director, Higher Education, Nanded. Our another guest of honor, Dr. D.D. Pawar sir, Registrar and Director, School of Mathematical Science, Swami Ramanand Tirth Marathwada Vidyapit, Nanded. And Dr. S.M. Jogdan sir, Principal and MC member, Swami Ramanand Tirth Marathwada Vidyapit, Nanded. We are also privileged to have to use today's our keynote speaker and well-known mathematician Dr. Prasanna Kumar BC, Professor, Department of Studies and Research in Mathematics, University of Shivnagari, Karnataka. Resource person, Dr. R.S. Varun Kumar. He has a lecture, Departments of Pure and Applied Mathematics, School of Mathematical Science, Sunway University, Malaysia, and Dr. Nandakishore S. Chandan, organizing. He has fellow of Oxford University, England. तुझं चालू आहे देख पण पडले अच्छा sorry sir, Dr. Nandakishore Chandan sir, organic chemistry, fellow of Oxford University, England, who have kindly accepted our invitation to share their insight and research expertise. His conference reviewed the wonderful response with 90 plus research papers and more than 100 registrations from all across India and abroad, showing the growing importance of interdisciplinary research between mathematics, statistics, computer science, and chemical science. Today, we are honored to establish a plan is the inspire knowledge and meaningful discussion. I extend my sincere appreciation to all dignitaries, guests, paper presenters, participations, and members of organizing team. Their invaluable support and contribution for these events. Thank you very much.
Thank you, sir. Thank you, convener Dr. Satish Chavan, for briefly introducing the idea behind this conference. Now, I request the chief guest of today's program. We are eagerly waiting to hear Honorable Vice Chancellor Manohar Chaskar sir to guide us on the occasion of this conference inauguration section. Chief guest, Dr. Manohar Chaskar sir, please.
Yeah, good morning. Can you hear me?
Yes, sir.
Yes.
Good morning, sir.
Good morning, one and all. Respected President of this institute, Professor Madharav Kinarkar sir, Principal, the Bokar College, Panjarav Chauhan, Director, Shailendra Devlankar, our Registrar, D.D. Pawar, Joint Director, K.L. Bondar sir, Management Council Member, Professor Jogdan sir, dear participants, faculty members, dear friends, it gives me a great pleasure to here today in this international conference of artificial intelligence in mathematical and chemical sciences organized by Arts, Commerce, Science College Bhokar in collaboration with Swami Ramananda Tirth Marathwada University, Nanded. I first congratulate to Principal Panjarav Chauhan sir and convener Satish Chavan. Both of took a lot of efforts to organize this international conference on very hot topic, and that is some application of AI in chemical science and mathematics. So they deserve for congratulations. At today, we are going to discuss on this platform the ideas, then fostering the collaboration and igniting the innovation with resource person with some delegates. It's a good opportunity to think on the AI, because the artificial intelligence is a type of a computer technology that can think and act as a human. Artificial intelligence can understand your words, remember the past conversion, and even learn the new things. Artificial intelligence can help us many ways. It can solve our problem. Really, it's an amazing technology. For example, wise, when we see, because it's a new field, it just started. And if you think on this, it's a combination of computer and the machine. Whatever we think, we hear, we learn similar way, the combination machine and the computer, they are doing all these things, and its application of the AI in agriculture, in disaster management, the climate change, the chemical science, the automobile industry. When we see one by one, we're going to example here, the only two example. One is, that is the in self-car driving. So how can we use the self-car driving? See, in the self-car driving, parking the car, speed of the car, turn the car, stop the car, read the signals. It is all through this AI technology. So you can think what's in the future in automobile technology. Second, agriculture is very important part of our life. In agriculture, when we consider as the Marathwada region, the main crop is soybean and the cotton and the sugar cane. The first priority of the soybean. So the farmer requires the technology. So faculty member, the student should think how to this AI will be implemented in the agriculture field, particularly the crop soybean. See, in the soybean, if you see the details, through the AI, we will going to find out what are the micronutrients, what are the macronutrients required. For the macronutrients, plant require NPK, that is nitrogen, phosphorus, and potassium. So how much potassium? Now today, what is our conventional methods? We are directly using lots of nitrogen, phosphorus, and potassium directly to the soil as a fertilizer. But artificial intelligence tells us how much quantity will be required, how much nitrogen required, how much phosphorus required, how much potassium required. This is a first application, this. And if it is a use, it helpful for the farmers. Then if you consider the disease, what type of the disease will be occur, where the disease will be occur. Then if you take the images through the drone, collect the data, send the information to the farmers, and before the 1 week, before the 2 days, inform the AI to the farmer, this disease will be occur, this particularly area and this particular part. So such type of the information will get very easily through AI. So we will get this information very quickly, and that indicate the life of the hour easier. Second important parameter of this for the Marathwada water, how much water required to the plants. This information also obtained through the AI. So my request to all the students, all the delegates, where and how we can use this AI in agriculture and as well as in the different field. It should be learned on the dais. The resource person definitely they will focus on the such applications, because the students, once they know what are the applications, then they will start to thinking how the technology will be used in this particularly area. One more thing is very important. They use the technologies very carefully and responsibly, because some of the disadvantages of this technology also. So you keep in the mind our responsibility also important. So I'm not going to much more talk, because resource person will give the lot of information regarding the different topics on the chemical as well as mathematical science. At the end only, I just this such type of the conference, it encourage continuously for the multidisciplinary type of the research, all the critical thinking, and whatever the excellence come out such by or through such type of the conference. I wish to the conference the grand success and look forward to reach outcomes that will be emerge from the today's discussion. Definitely, Punjab Rao Chauhan and his team took a lot of efforts. Similarly, and the topic they selected, that is very new topic, hot topic. And as the Vice Chancellor from the university, my best wishes with all of them. And definitely, after the 5 years, 6 years, college should start some courses on the AI-based courses. That is the need of the society in the future. So once again, congratulations and thanks you very much. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir. Thank you from our chief organizer and all organizing committee. Thank you, sir, for guiding this magical technology in a very simple way. You have also focused how this technology is useful everywhere in biochemical science, chemical science, physical science, or even very needed area surrounding this Marathwada, that is agriculture. So how it can be reduce the cost and side effect from fertilizers for appropriate use of water and for appropriate use of fertilizers to avoid its cancerous or cancerogenic side effects on health and society. So thank you, sir. You also focus on this, the disadvantage of this technology. So we'll obviously your guiding speech will give us strength and confidence, and as our blessings from our president, Honorable Sri Madhavji Patel Kinarkar, ex-minister, also his visionary strength guiding us to organize this such type of conference in the guidance of our respected principal, sir. Now, with this remarkable talk, I would like to invite beloved principal, respected Dr. Punjab Chauhan, sir, for his presidential address. Sir, please, Principal Punjab Chauhan.
Hello.
हाँ, sir.
Sir,
Devulankar, sir, is there?
Bondar sir's address, please.
Okay. So, excuse me, audience. Before that, we are having the guest of honor, Dr. K.L. Bondar, sir, Joint Director, Higher Education, Nanded. So, he is addressing this international conference. So, I request Bondar, sir, to please guide us.
Thank you, sir.
Yes, welcome, sir.
The chief guest of today's function, our beloved Vice Chancellor, Chaskar Sirji, Principal of this college, and all the participants. Actually, our director, sir, is in some another meeting. That's why he couldn't join this meeting. So, from myself and from him, to of this region, we know that this AI plays very important role in new syllabus, which is to be implemented as per NEP also. We know that courses, verticals like VSC, courses like SEC, courses like CEP, we can take use of AI to make the courses, make the such courses by using artificial intelligence also, and which will be helpful to all students. So once again, I wish all the best to this conference and hope that it will be helpful for all the peoples. Thank you.
Thank you, sir. Dr. Kiran Kumar Bondar, sir, your short message and this inspiration and your consistent guidance and visit to our college, physically guiding our students and our faculties will definitely encourage our academic and research excellence. After this, now I will I request our another guest of honor, Dr. S.M. Jogdan, sir, Principal and MC member, Swami Ramanand Tirth Marathwada University, to guide us on the occasion of this international conference. Come on, sir.
Hello,
Hello, sir.
sir. Presidential address.
No, नाही येत का?
सतीश जोगदंड सर नाही सतीश जोगदंड सर
सर आहे तर त्यांच्याकडे कार्यक्रम चालू आहे ते मीटिंग मध्ये बसून येत तिथं ते आज शिवजयंती काहीतरी कार्यक्रम असते म्हणून कंधारला
हो हो ठीक.
त्याच्यामुळे ते हे आहेत.
बरं ठीक. डीडी पवार
due to-
बोलणार आहे.
पवार सर बोलणार नाही म्हणले साहेब बोलल्यावर विषय सर.
बरं बरं ठीक आहे.
हो.
Thank you, sir. Thank you, Chavan, sir. As you know, due to technical and his meeting, our guest of honor will join us later. Now, I request Hilliard Principal Punjab Chavan, sir, to conclude his presidential address over this international conference. Respected Punjab Chavan, sir.
राघव सर साहेबाचा आवाज येत नाही मी उठायचं आहे.
Excuse me, sir.
Sorry. Honorable Devlankar sir has visited our college as the keynote speaker of a conference.
Yes.
Our college is committed on excellence of spreading education in rural surrounding under the visionary leadership of our president, Dr. Madhav Patil Kinalkar, former minister of Maharashtra State. We are progressing day by day. Now we have for postgraduate department. The college has been rewarded with many prestigious awards like the Best College Award, the Best Principal Award, etc. The world has reached a remarkable stage of the era of information technology. Now we are in the era of artificial intelligence. With us, with use AI, we can break the boundaries of different disciplines. In research, we can combine traditional methods and AI in a more fruitful way. It will help in finding out real solution of global challenges in mathematical and chemical research. AI is unlocking new possibilities. AI assists the solving complex equation and simulation of abstract ideas. This conference serves a platform of scholars, researchers, and experts from around the world to research, to exchange ideas, share their advanced work, and inspire future collaboration. There are different sessions in this conference to discuss different things. I believe that the participant will make the most of this session. I congratulate the organizing team, the selecting in the emerging topic, and I think Honorable Dr. Devlankar sir, Honorable Vice Chancellor Dr. Manohar Chaskar sir, and all the prestigious speakers and participants for being part of this conference. With these words, I declare the conference open. I wish great success of the conference. Thank you.
Thank you, sir, uh, for your presidential address. Sir is not only focusing on AI, he it is giving a large possibilities how it can unlock the complex dynamics and simulation in mathematical science, and how the complexity of chemical in chemical science to resolve with the help of AI for the sustainable development in science and technology. So, with this presidential address from our principal Punjab Chavan sir, now we are in the last phase of this inaugural ceremony. Now, I request uh, convener Dr. J.D. Kotapalli sir to propose vote of thanks for this inaugural ceremony.
Thank you, sir. I am audible, sir.
Yes, sir, you are audible.
Thank you, sir. Good morning, all of you. I would like to extend my heartfelt gratitude to each and every one of you for joining us today to mark the inauguration of this international conference. I would like to express my sincere appreciation to our chief guest, Vice Chancellor of Swami Ramananda Tirth Marathwada University, Nanded, Honorable Dr. Manohar Chaskar sir, for gracing the occasion with their presence and sharing their valuable insight. I thank the inaugurator of this conference, Honorable Dr. Shailendra Devlankar sir, Directorate of Higher Education, Government of Maharashtra. I also thanks to presidents of this conference, respected Dr. Punjab Chavan sir, principal of our college. I would like to thank guest of honors, Dr. K.L. Bondar sir, Joint Director, Higher Education, Nanded, Dr. D.D. Pawar sir, Registrar from Swami Ramananda Tirth Marathwada University, Nanded, Dr. S.M. Jogdan sir, Management Council member of Swami Ramananda Tirth Marathwada University, Nanded. To our keynote speakers, I extend my gratitude for setting the tone for this conference with their thought-provoking presentations. To all the delegates, speakers, and participants, I welcome you to this conference and look forward to engaging discussions and deliberations over the next sessions. I would also like to acknowledge the tireless efforts of our organizing committee members who have worked behind the scene to make this conference in reality. Thank you all for your participation, and I wish the conference a grand success. Thank you very much, sir.
Thank you, convener, for proposing a vote of thanks to everyone. And obviously, we are having very dynamic session ahead. Now, with the end of this inaugural ceremony, uh, we are going to soon we are going to start a technical session. As we know, we are eagerly waiting to hear today's keynote speaker, Dr. Prasanna Kumar, PC sir, Professor, Department of Mathematics, Devangiri University, Devangiri, Karnataka, India. Now, to introduce this dynamic personality, may I request Dr. AKPV to introduce our keynote
Thank you,
speaker,
sir.
Dr. Prasanna Kumar, BC sir.
Thank you, sir. We are in the first technical session, that keynote address. I am here to introduce Dr. Prasanna Kumar BC, Professor, Department of Mathematics, Devangiri University. BC Prasanna Kumara sir has obtained his PhD degree from Kuvempu University, and he is currently working as professor in the Department of Mathematics, Devangiri University. His research focuses on both fluid and solid mechanics. He has developed mathematical models and simulation pertaining to thermodynamic performance of nanofluid. His work centers around the study of heat and mass transfer through fins, micro, and nano channel and over a stretched surface. Prasanna Kumara has impressive publication record with more than 250 articles in national and international journals. He has 10,000 plus citations with H index 62, and his I10 index is 194. It is a commendable uh, specialization effort in mathematics. As a PhD guide, he has guided five students, and he has worked on several boards. His publications include the publishers like Elsewhere's, Springer, ASME, Emerald. He has been awarded with Simi Raman Young Scientist Award by Government of Karnataka, seed money for young scientists for research, vision group, and science and technology, Government of Karnataka in 2014. He has many prestigious awards in his bag. To have such a great personality to discuss applications of AI with us. Sir, please guide the occasion in your keynote address.
Thank you, sir. Thank you, Take sir, for briefly introducing today's keynote speaker, Dr. Prasanna Kumara sir. Now, as we are eagerly waiting to listen this thought-provoking and a very interesting topic over this magical technology, so I request Dr. Prasanna Kumara sir to uh, guide us in this keynote speaker address.
Sir, thank you so much. I hope, can you hear me?
Yes, sir. You
Sir,
are
thank you
audible.
so much. Thank you so much for inviting me for this international conference. Thanks to the organizers. Very first, as a matter of fact, let me express my sincere thanks to organizers and also my friend Deepak Sarve, who introduced me to the organizers. And I'm very happy to deliver a keynote speak, particularly on artificial intelligence. And I am also happy that one more speaker is my student. He is working in Sunway University, and he is doing a very good work on artificial intelligence, particularly application of artificial intelligence in heat and mass transfer problems. He is doing wonderful work. He published many good papers, and he is working with many foreign collaborators. I'm very happy that he is also delivering a talk, and it will be a continuation of my talk, and it will explain all in detail. He will explain in detail how the things are going in application level. So in present talk, let me share. Okay. I hope, yes, it is moving, right?
Yes, sir, it is moving and it's very,
Yes,
very
fine.
clear.
Then it is fine. Sometimes
Yes.
what happens, this won't move at all. It is moving, right?
Yes, sir. Yes, sir, it
Okay,
is
fine.
completely okay.
Okay, fine. So, in the present talk, mainly I will concentrate on some basic problems. But these problems can be extended. This concept can be extended to any sort of linear and nonlinear problems. Even I wonder, this AI tool giving a very good accurate, almost 97, 98% accurate result for highly nonlinear problems. Even with my team, I am working on both fluid and solid mechanics. Of course, solid mechanics problems almost second order, but even sometimes it is highly nonlinear also. In that case, we are getting almost exact result, almost 99% accuracy we are getting. But I wonder, in fluid mechanics problem, as you know, this is a coupled equation we solved. And in that coupled equation, is a highly nonlinear, even boundaries are nonlinear. Still, this method we are getting around 96% accurate result. So, in the present talk, I will concentrate on some basic concept which many of you know, and also later I will discuss with one of the heat transfer problems. Okay? See, another 30-40 minutes we will discuss on that. And my primary aim of this talk is to create an interest and awareness among the audience. And also those who are working can also think of applying this artificial intelligence in heat and mass transfer problems, that is in fluid mechanics. And as I already have told, I am working both fluid and solid mechanics. Interested candidates, interested professors, those who can collaborate with me in this area are most welcome. So, artificial intelligence directly. So earlier, actually, we used a very basic artificial neural network. Now we are using very advanced physics-informed neural network. Later, I will explain what are the difference between these two, very basic ANN and to the advanced networks, and how we are using and in which platform we are using. Everything we will discuss in detail. So as we know, oh, this is the pictorial diagram. So, deep learning, machine learning, artificial intelligence, these are the words all concerned with this artificial intelligence only. This is a big set. Artificial intelligence is a big set. In that we have deep learning. It is a small set. And a bigger set is machine learning. And very bigger is artificial intelligence. And within this, we study most of the machine learning related, of course, I should say almost AI, artificial intelligence techniques. So the big set, these are all concerned with AI only. Okay. So what is artificial neural network and human brain nervous system? These are one and same. These are one and same. You see, this is our brain diagram. So self-institution, speech and all, this is the biological things. And I'm not going to explain in depth. So only surface level I'm explaining, as already I have told, my interest is to create an interest and awareness among this ANN. So in brains, we know there is a neurons. This is one of the pictorial notations of neurons. So main thing work is here dendrites. These dendrites will pass to the another dendrite through axon. And this is what actually our brain system works, and we have across together billions of neurons in our body. And through this neuron, the signals will pass from one point to another neuron, and then finally the destination, that the brain. See, this is how it works. So through dendrite, it will receive the signals. It passes to axon, and again through another dendrite, it will receive another neuron. This is what it happens. See, around 100 billion neurons create a neurons network by connecting with each other. This is the thing, biological system, and everyone knows this. Biological neuron is made up of cell body, axon, and dendrite. And cell body, these are all biological words. And the same biological words, we keep it, and we will connect it to the machine. So these are the few things that you should know about our brain, how it works. So ANN similar portions we connect, but these are just an imitation of neural network. It is imitation, just how our brains work. Same concept we are applying in ANN also. So this is the thing. See here, main thing is nucleus, dendrites, axons. Dendrite receives through axons, it passes to the another thing. And here also you see these are input x0, x1, x2, x3, so on, xn. These are the inputs. And these are the output, W1, W2, W1, these are the output. And B, it is important. This is the initial condition. B is important. That always I connect with the first input. And the linear function I should choose. That is a linear function I should choose. And activation function also I should choose so that it applies to the present input data. And output I will get it. See these inputs x0, x1, x2, xn, these are like dendrites. And through this, it will goes to a nucleus. And that process and passes to the another one output, and again that will receive and it passes. This is how it actually works. A biological neuron receives an input signal from other neurons through dendrites. Likewise, artificial neuron receives a data from the perceptron through input neurons that take numbers. This is the same thing as I already told. It will receive from here. Okay. So working of artificial neural network. So one few simple sentences I will explain because I would like to concentrate mainly on how mathematically it works. That is the my first idea is. See here, these are x0, x1, x2, xn. These are the weight function. These are the input, and it is an artificial neuron. And here I should choose linear function or activation function. Both we need, and output will go. And this is we say perceptron. In comparing with our brain activity, this is where we say it is a perceptron. See, this is the mathematically I have explained. W1, x1. See here, it goes, and this one you see x0 is equal to 1 and B. This one is important. That is the initial condition that you leave it. Now you take this one x1 W1, x2 W2, x3 W3, so on xn Wn. See here, W1 x1, the W2 x2, so on W1 xn plus B. Plus B is that first condition, initial condition. Or we write in terms of series y is equal to B plus summation n from 1 to m Wn xn. N varies from n from 1 to m. This is what we did. This is a mathematical. And here weight, bias, and activation functions are three major ANN parameters. So weight, how we are putting a weight, and what are the bias, what are the activation function we choose. See, I have explained here, weight transfers the input node into the hidden layer of the network. Here we have hidden layer. Hidden layer means all calculations will take place. Weight transfers the input node onto the hidden layer of the network. The weight multiplied by the input. Always weight we multiplied with the input. And bias is another important character in ANN, representing how far of the output values are from the intended values. The bias value is added to the multiplication of input and weight before passing to the next step. So this is adjustment. Bias is we have to adjust so that I should get a desired accurate output. Okay. Lastly, activation function or differentiable function added to the AN to help the network to learn complex pattern of the data. This is what sometimes you see, this is very basic I am explaining. So this activation function is not required where if you use physics-informed neural network. I am using a basic thing I am explaining. So in the basic artificial neural network, we need activation function in order to adjust to the input function. Otherwise, I should say that machine should understand what type of input I am giving. Suppose I am giving the data of how the temperature varies from T is equal to 0 to T is equal to 1. Suppose you take unsteady parameter. So then I should machine should understand that this is what happening. This whether this temperature is varying linearly or non-linearly or according to exponentially, like that I should choose it. According to that, I have to choose the activation function. Later, I will explain in detail what are the activation functions are available to choose it. So now numerical example I will take. This is a simple example. Let us take three input values. X1 is equal to 2, x2 is equal to 3, x3 is equal to 1. I have taken three input values. Since we have 3 inputs, we also have 3 weights to control the level of importance of each point. I have chosen, assume the following values in. See, these are just for example, but when we are choosing original data, these most of the things are not required, because if you use advanced neural network, it will adjust itself. That I will discuss later. But I am giving very basic example. Let us assume these values are 0.5, 0.2, and 10, and bias unit will be b is equal to 2. This is what this basic input. Okay. Therefore, the linear function I have to w. So these two, x1 w1, x2 w2, x3 w3 plus b. That formula I have explained earlier. Same thing. x1 w1, x2 w2, x3 w3 plus b. It becomes linear function calculated as 13.6. According to the input, I have calculated z is equal to 13.6. Okay. So, and output y based on the type of activation function we use. Now, output is depend on what is the function that I am going to use. So, suppose I use sigmoid activation function. Same, but different activation functions are available, in which I use sigmoid activation function, and sigmoid activation function is given by 1 divided by 1 plus e power minus z. See, the output y is given as sigmoid 13.6 of this, 13.6 of z I have used, and it is given almost y is equal to almost 1. Okay. See, so now pictorial notation 3, 2, 1, x1, x2, x3. Their weight 0.5, 0.2, 10, and a bias function 2, and this x1 w1, x2 w3, x3 w3 plus b will become 13.6. And I have to choose a sigmoid activation function. I have to choose. I have choose sigmoid activation function, and I got output is equal to almost 1. Okay. So this I will explain in terms of architecture of artificial neural network. I will explain now. See, you don't confuse with the previous example. See, just this is a simple example I have given. Now I know you have many doubts. Very first one is how you choose f. Why you choose a sigmoid activation function? So all these concepts are depends on the data that we are going to give. So that we will if you are going to use very basic ANN, this plays an important role. Otherwise, this not a pleasant role at all. Okay. This is the architecture of neural network. This is the input layer, W1, W2. It goes to the hidden layer. Calculations have been done. It goes to output layer, and output will get it. And these are the things you should know. Input layer means it contains artificial neuron units. Output layer, it contains the processed one. And hidden layer is the one in which calculations have been taken place. So these characteristics of artificial neural network. This is nonlinear, non-limited. So nonlinear, wherever nonlinear comes, it always very difficult. But here it is very good for nonlinear relationship establishment. And also it is non-limited. It is not limited to for any. So this only this case, that case. No, it is not like that. And it is non-qualitative. Artificial network is self-adaptive. It is self-recognizing, self-learning ability. Therefore, it is non-qualitative. So you're only this much, that much. No, not like that. It is non-qualitative. It is a self-adaptive, self-organizing, and it also self-learning ability and non-convexity. And this is having evolutionary direction of a system under certain conditions. I'm telling under certain condition, it is non-convexity also. So these things you will wonder later. See, when you are using a basic artificial neural network, this may be for some extent true. But when you use a very advanced neural network, advanced AI tool, then everything you will wonder how we use it. Yes, you will appreciate all these things, particularly non-linearity, non-qualitativeness, it's not connectivity, and everything you'll appreciate. This advantages of artificial neural network. This adaptive learning. This is it. It adapts its learning based on the previous learning experiences, and it is a self-organization. It organizes it. Depend on the input data. It organize self-organizations also will happen, and real-time operation is possible. and fault tolerance via redundant information coding. See, for example, some input data may be not good, maybe fault. Then fault can be rectified by using redundant information coding also. See some importance. So it takes time. I will not discuss in detail. Directly, I will go to some mechanical problem. And this thing, I think it is important to know. So we have two different type of feed forward neural network, feed backward neural network. See what happens in feed forward neural network. So once the input data is given, it will be processed in the hidden layer and output will get it. But in what feed backward neural network happens, if output data is not of desired accuracy, then again it will go for input. So then again process will be there. What it means, output data will again serve as an input data. So this is a feed forward neural network I am telling. So input, hidden layer, output will come, again output will go to input layer. So this is, that is forward, it's over. So but feed backward neural network, again output it is not good, it will go to hidden layer and it process will happen. And even sometimes that output I can give it to the input as well. So here if you choose a feed backward neural network, then output layer again it goes to hidden layer directly and updating the weights and calculating errors. It will update the weight function what we have chosen, it will update. So need of back propagation always good, and we are using this back propagation. So because it rectifies our errors, even it rectifies by using auto rectification of weight functions, it will give a good output. And training data of artificial neural network. You see, data will be available. In that data, how it works, that is also important. First, you have to divide the data into training data, testing data, validating data, like that. So first few data, I will train the machine. I will take some data, and by using that data, I will train the machine. So then I will test that. This training data is over. See, the available data, you make it three groups. In the one group of data is for training, another group of data is for testing, another group of data is for validation. So first group of data, you train it. You train the machine by giving input. And then later, what you have to do, you go for the testing. That data you give it and verify whether it is correct or not. Then it is validation. The validation is very important stage. Once you got desired valuation, you go for the actual work. So training data test, validation, and test data. These are the different type of neural network. So multi-layer perceptron neural network, radial bias function neural network. Yes, so many neural networks are available. But finally, that physics info neural network, it is very important. It understands the physics of the problem. So by giving the data, the machine itself, it understands that you are using a heat transfer problem. Okay, you are using a velocity of a fluid. Like that, it will adjust. It will understand itself. For that reason, this PIN, physics informed neural networks, is very important and very useful now. And even we used extreme learning machine and recurrent neural network, and many neural network options are there. See, these are the few applications of neural network. And now directly I will explain one problem which we published along with my student Varun Kumar, that he is going to explain in detail in the next class. Modeling of the problem. See, this is the speed. Actually, in this present paper, we have used non-Fourier thermal analysis of a moving plate. On moving plate, we are using that non-Fourier thermal analysis we use. and BAP propagated neural network modeling we applied. This is a old paper, 23 paper actually. So this is the formulation things that the study explicit the unsteady energy transfer through a moving plate with thickness, length, and width, and plate dissipate heat to the fluid around it, convection and radiation. The plate is moving horizontally in the x direction in the constant speed u. Like that, we have made many. These are the formulation section. See like this. This is the length of the plate, width, and height of the plate, the delta, thickness of the plate, and it is moving in the horizontal way, is moving at the speed of u in the flow. So these are the equation, concerning equation with respect to our conditions which we consider in the formulation section, and these are the boundary condition, appropriate boundary conditions we used. Okay, and this is the dimensional form I have applied because it is in dimensional form. It is in dimensional. I did non-dimensionalization, and this is the non-dimensional equation we have. Okay, and these are the non-dimensional parameters we got, and we applied now artificial neural network modeling. So we used preliminary data by FDM, finest difference method. We got preliminary data that is generated. I have made 3 subgroups of data that have been generated with 70%, 15 and 15% of the total data points being used for training, validation and testing. So I used 3 total data which I have obtained by FDM. I have made it 3 groups. One is 70% I use for training. So that mainly I use for training. Another 30%, 15 for the testing, another 15% for the validation. See, this is the input layer, hidden layer, output layer, and I got the output. This is what it happens. See, this is the pictorial notations. I have used it. This is the formulation, governing equation. This is the what we say dimensionless form of a boundary governing equations, and this is what we applied, and we got what we got this. Okay, see. Actually, we applied your LMA, Lineberg-Marguerite algorithm to train the artificial neural network. Okay. And this is what different transfer functions we used in the hidden layer. And this is what the FDM, we applied that FDM I showed here. And these are the different working flows of ANN. First, you have to collect the data, input and target data, splitting of data into hidden neurons, ANN training, comparison of numerical and predicted data, choosing ANN model, prediction. See, so here, as I have told, I have obtained the data, around 1,000 point data I have applied, around 500, 600 I have applied. I made it 3 groups. 70% of the data which I applied, I have used it for training the machine. Another 15% validation. That after training, I should ensure that yes, machine is trained. Then another 15% I will check it to check whether training and validation is done successfully. That I will use. Okay, and well, particularly for this problem, as I told, it is a old paper. There I used a basic ANN. And you see, these are the data I got. Scenarios and case by varying thermal parameters. Different thermal parameters, I got different data. So first scenario, second scenario, I made different groups. Okay. And training performance, you see, I got training, validation, testing. This I did. First one is training, validation, and testing. And you can see that this is for 64 epochs. I did it. But you can see that this is not so good. But for 64 epochs, I have applied. Okay. And the same 64 epochs, I have trained it. And this is training data for say NC. This is, see, these are the our mechanical words. So NC, NR, Packard number, beta, and these are concerned with our mechanical problem which I have considered. For all this, I have trained it. I have trained, and I have got this is for 64 epochs. Generally, I get it, and for NC, I have checked. Similarly, this is the for error. This is the training data, validation, testing, and zero error. You can see that this is giving most accurate solution for the, and you can see that most of the data I'm using for training. And training and validation, testing, and you see all I am getting R is equal to 1. Here, R is equal to 1 indicates that we can move further. We can move further. Training also, I have got an accurate R is equal to 1. In validation section also, I got R is equal to 1. And testing, and in both targeted levels, I am getting R is equal to 1. Okay, then I can proceed further. And this is the fit curve plot for varying NC. I have checked it, and you can see these are the different things I have applied: training outputs, training target, training output, validation, test target, and everything. You can see that it is on the line. And here also you can see that thermal variation plot for varying NC. NC for different values I have got it, and this is exactly what we expected and what we got in mathematically also. Okay, so this is the error analysis. We can see that how error varies with respect to the time x-axis and with respect to AE, the absolute error. And training performance plot for varying Packard number. This is those I have considered for the different parameter, and here for the Packard number I am using, and you can see that Packard number epoch is 56. Now for the 56 epochs I have to see, and you can see that the graph is also very different. Okay, and for that varying Packard number also I have got R is equal to 1, so I can proceed with Packard number also, and you can see yes, it is correct. And for the Packard number, this is the in the result which I want, and we can and I verified that result is exactly yes I required. And when I compare to the mathematical output, this artificial intelligence output is also coincides. And this is the for Packard number. This is the error analysis I did, and this is for QIG again for different parameter I did, and you can see, and there also it exactly goes for our according to our wish. And for error analysis also you can see that. And now I will compare our ANN result with FDM results with varying NC. You can check it 10 to the power -5, -6 accuracy result you can get it. So this is very simple problem, and this numerical analysis finite difference method gives almost 10 to the power 9 accurate result when compared with the exact solution. Therefore, our ANN is also coincides and exactly giving almost exact result as FTM. It means that when I compared ANN with the exact solution, our results gives a good validation. And this is also for different VE number, and you can see that in some cases I am getting 10 to the power -9, sorry, -7 accuracy. And so this is the thing I am getting for the you see training, validation, and testing. 10 -9, -10, -11 accurate result I am getting. -11 accurate result I am getting. So therefore, no doubt it is useful for it. Okay. So final conclusion. These are all that are concerned with my problem. Okay. So thank you for your patience listening. And actually, I wanted to give more information when you for the discussion section, because you will ask. So okay, your FDM is available. FDM method is already available for to solve such a simple problems. Then why you go for ANN? So I hope you have this doubt. As of course, even my students ask the same question. Sir, I already FDM, we are getting accurate solution. Even exact solution is also possible for simple problems. Then why we need ANN? So the answer is just to verify, just to show that yes, ANNs also gives exactly as FDM, exactly as exact solution. I used this one. But now later I applied for very different problems where we cannot get 10 to the power minus 9 accuracy for all sorts of problems. And ANN giving particularly this physics info neural network AI is giving almost 10 to the power of minus 9 accurate solution where we are not getting even with numerical one. Okay. So like you must be having many different queries regarding this artificial neural network. Please go ahead. I'm very happy to discuss with you because I'm not going in depth with these things. My student will definitely will explain in the next class. Okay. Yes. So, dear friends, now it is a free time to discuss. As I told, my intention is to discuss. Please, any queries? Please get me know and we'll discuss in detail. So if you have any sort of doubts or any sort of explanation you want, I am happy to share information on that. Huh? Overfitting. Yes, it's correct. So one question is asked, Anjali Yashwant, overfitting and other things. You see, even overfitting is one of the problem in ANN. That's why we need testing, validation, and this training, testing, and validation section we require. So this question my student will ask in detail with example. What happens if overfitting is there? Yes, anything else? Because it is an opportunity to discuss with a different part of our nation. So this is my first conference in Maharashtra. Okay, if you, Sir Jadhav sir.
Hello, sir. Hello.
I think Jadhav sir, we are not getting your voice.
Hello.
Hello.
Yes, sir. Hello, sir. Hello. Hello.
Hello.
Yes, sir.
Hello. Yes, sir. Sorry.
Ah.
Thank you, sir, for your wonderful session. It will be definitely a thought-provoking in area of neural network
Yes.
and machine learning through these mathematical models. Now we are going to start session first with resource person Dr. K.S. Varun Kumar, sir, on a predictive analysis. To introduce this dynamic personality, I would like to invite Mr. Tarun Sinde to briefly introduce our first session resource person, Dr. K.S. Varun Kumar, sir.
Good afternoon, everyone. It's my pleasure to introduce our next resource person, Dr. R.S. Varun Kumar, sir. And one of the interesting fact about Varun Kumar, sir, they are working as assistant professor in Malaysia. Sir also contributed a great research work, and I have been fortunate to contribute total 76 journal publications and publications with guidelines of Dr. B.C. Prasanna Kumar. Sir published divided across the different categories of research papers in a different kind of journals. Each of these categories represents a unique aspect by commitment and advancing knowledge and engaging a variety of scholarship platforms and have a great work on mathematics also. Sir, please join now. You may join now. Thank you.
Okay. Thank you, Doctor. Thank you for your fruitful words. First of all,
may I request
sorry. Can you hear me? Hello.
Sir, you are
Yes,
audible.
Varun, carry on.
You
Varun,
may
carry
join
on.
now.
Yeah, please.
Carry on.
Okay.
Varun, carry on. We are hearing you.
Okay, sir. Thank you. Good afternoon, everyone. First of all, I would like to thank the organizing committee and my supervisor, Professor B.C. Prasanna Kumara, for giving me this great opportunity. So today, first I will share the screen. So wait a minute. It's downloading some background package. So please bear with me. So it will going to take 1 minute. Okay. Is it visible now? So can you hear me?
Yes, sir.
Yeah. Thank you. I am Dr. R.S. Varun Kumar from School of Mathematical Science, Sunway University, Malaysia. So today I am going to talk about physics-informed neural network in relevant to the heat transfer phenomena. So you may ask me why I have chosen the heat transfer phenomena. So the answer is very simple, because heat transfer phenomena has many application in the real world scenario. So in a short, we can say that, for instance, the heat transfer from sun, it is another type of heat transfer phenomena, that is radiation. And in the automobile applications and industries, we may came across the heat transfer phenomena. So that's why I am interested in explaining the heat transfer phenomena using physics informed neural network. So over next 40 minutes, I will be going through these concepts, that is basic of artificial intelligence and working of the neural network, application of neural network, that is particularly the physics informed neural network, by considering a heat transfer problem. And later on, I discuss some results. Finally, I conclude the session with corresponding future ideas. So I'm just adding some more information to the keynote address. That's it. But I majorly focus on physics informed neural network. But one should know what is the artificial intelligence. So artificial intelligence is nothing but a technology that is used to mimic the human being thinking capacity or the cognitive skills. For example, humans can take the decision according to the input. If we consider, if I feel cold in a air condition, so I can wear jerkin or jacket or another cloth, whatever. So in the similar manner, the AI should take the decision. So that's the main motto of the concept artificial intelligence. But the most of the artificial intelligence are data driven method. Means we are giving some data. So those are the real world data. So we can say that the cancer patient data or some heat exchanger data. Depending upon the data, the machine should analyze some pattern, and based on the pattern that will give the predictive results. So that's the main motto of artificial intelligence. That's why this artificial intelligence become more popular. So as our professor told already, the artificial intelligence can be viewed as a big data set. So in turn, it has machine learning and also deep learning. So machine learning is also a part of artificial intelligence that replicates the human nervous system. Here, we are going to give the data and based on some algorithms that will provide the accurate result. And in the deep learning, it's a collection of neural networks. It's an intercollection of neural network. So for example, in a broader sense, we can explain like this. So I believe that you know about the Siri feature in your iPhone or any other higher end systems. So what does the Siri perform? Siri can do basic tasks such as setting the alarms or finding the location and etc. So this can be taken as a AI information, I mean artificial intelligence, and in turn Siri can learn some pattern that you are going to give the voice command. So when you are going to give the voice command, that analyzes some patterns in your voice, and that can act as a machine learning. So what about the deep learning? The Siri can transform or convert your speech into some text form. So that can be the function of deep learning artificial intelligence. So based upon several features, we can differentiate the three components: artificial intelligence and machine learning and deep learning. When it comes to the optimal data volumes, artificial intelligence requires more data values. Similar to this one, machine learning and deep learning are also required more data, and the output will be like kind of classification or pattern recognition in the artificial intelligence, ML and deep learning. The artificial intelligence works without the intervention of the human beings, but it provides accurate results. So in the same manner, ML involves some algorithms. The deep learning involves the set of neural networks in order to work. So how it can be managed? So it can be managed without the human intervention. So that means we are already modeled the artificial intelligence by giving pre-data. So using this data, the ML or AI or DL has to produce the predictive results. The ML is mainly dependent on the given data. Deep learning is largely dependent on the giving data, meaning whatever the hidden pattern is there in the data, according to that hidden pattern, we are going to get the corresponding result. So it is important to mention the machine learning history, because one should know when the machine learning has been introduced. So in 1950, this machine learning was first proposed by Arthur Samuel, and in 1957, Frank Rosenberg, he introduced the concept of perceptron. So this is the basic building block of the artificial neural network. And we consider first and second winter of AI is the progressive era in the artificial neural network. And the three persons, namely Ion, Bengio, and Jeffrey Hinton, they contributed more to the field of artificial neural network. And one more important one more important fact is Jeffrey Hinton. So he reached more than 9 lakh citations till date. So he is known to be the godfather of AI. So his contribution is immense. And also the Canada is recognized as a mecca of AI. So with all these history, we can discuss the next things, that is application of artificial intelligence. You may wonder why this artificial intelligence is becoming more popular. So that's because of its artificial intelligence application. So if you consider most of the sectors like computer electronics technology, financial services, and healthcare, so in all of the sectors it has its importance. So that's why the artificial intelligence become popular. And I would like to thank the organizing committee for giving such a wonderful concept, the application of artificial intelligence with respect to the mathematical problems. So first we can discuss the individual artificial intelligence techniques. So we know that machine learning, it is also the type of technology that mimics the human thinking. This machine learning can be broadly classified into supervised learning, unsupervised learning, semi-supervised learning, and the reinforcement learning. In the supervised learning, the training will be done with the known labeled data. Whereas in unsupervised learning, we don't have the labeled data, but still it produces some classification, this or that, whether the given input is classified or not. Like that, we can get the classification. And in the semi-supervised learning, it is a combination of both supervised and unsupervised learning. Then what about the reinforcement learning? So in the reinforcement learning, we have an agent, and we are going to train using the corresponding agent, and error will be reduced there. So this one is the broader classification of machine learning. So you may observe that machine learning has main categories: supervised learning, unsupervised learning, and reinforcement learning. All these classifications are subcategorized into clustering, dimensional reduction, classification, regression, and what so not. Out of these machine learnings, the majorly applied and the most relevant is supervised machine learning, because we can use it for the regression kind of problem and predictive analysis. So now the working of biological nervous system. So already our professor has explained it, but I'm going to add some information to this one. We know that the deep learning contains the interconnection of thousands of neural networks or millions of neural networks. So how this concept comes, how this concept evolved, that's because of the human nervous system. So human nervous system works in an interconnected region. So in the similar manner, the researchers or the investigators replicated the brain system of a human being to an artificial neural network. So this is the pictorial representation. So there are three main components in the biological nervous system. One is dendrites, another one is neuron cell body, and axon. So dendrites, it receives the input signal from outside the world or from another neuron. So some particular calculations are done in the nucleus body, and the corresponding response will be sent to the another neuron. We already know that the neurons are interconnected, and that forms a neural system, nervous system. So this axon will be the connective path, or we can say that the electrochemical signals will be passed from this axon. And the synapse, it's a connection between axon and the dendrites. So here the dendrites also act as a output function or the output layer, or synapses acts as a output layer. So this is how the human brain system works. So in the similar manner, we have artificial neural network. So whatever the function dendrites does, that will be performed in the input layer, means it receives the input from the outside world. After that, that will be sent to the hidden layer with the connection, that is the weights. So in the brain neural system, I mean human brain nervous system, axon act as a connection. So here also weights act as a connection, and finally we have to get the output. That output will be given by the output layer, in which it is connected to the hidden layer. So we can compare the working of biological systems and the artificial neural network. So the dendrites, so here are the inputs x1, x2, x3, so on, xn, that will be received from another neuron or the outside the world. I mean, in the outside the world means from the sensory organs. So dendrites receives the inputs, so it sends to the neuron or the cell body. Some calculation will be done here. The response will be sent through the axon. So here it is the axon. So that will be the given output, that is y1, y2, ym. In the similar manner, the input will be obtained from the outside by input layer. That input layer is sent the received input to the hidden layer. The hidden layer performs some calculation, and the output will be sent to the output layer, and finally we receive the output. So this one also Professor Prasanna Kumar explained, but I'll give a short note on this one. So we have the inputs x0, x1, x2, so on, xn. These inputs are sent to the artificial neurons by the weights w1, w2, w3, so on, wn, plus bias. So the main components of perceptron artificial neuron is linear function and the activation function. This linear function receives the input in the form of linear combination of inputs into weights plus bias. The main hyperparameters in the artificial neural networks are inputs, sorry, not the inputs, weights, bias, and the activation function. So these are important parameters. We should take care of these parameters. I mean, in order to get the less error or minimum error, we need to optimize these parameters. So the linear function we can mathematically represent as y is equal to b plus summation of wi into xi, and the activation function act as a plot form or the main plot of the neural network. So it decides, it finds the pattern hidden in the data set. Now we can see the different kinds of activation function. The first one is linear function. So that is f of x is equals to x, and unit step f of x is equals to, that's the stepwise function, and piecewise function, log sigmoid function, tangent sigmoid function, and radial basis function. So here we can easily see that the mathematical functions are involved in the artificial neural network. So that's why the computer science, I mean the artificial intelligence, is based on computer science, data science, as well as the mathematical definitions. So one should know how to import the mathematical expression into the neural network. So again, the data set. So data set is very important. So here the method is very simple. Artificial neural network or the artificial intelligence is a data driven method. Means the output will be obtained based on the hidden pattern that we are given to the data. I mean, based on the hidden pattern in the data, we receive the corresponding output. But the given data is divided into subcategory in order to get the predictive result. The first one is training data set, validation data set, and the test data set. This training data set is used to fit the parameter. For example, weights, the weight values. Professor explained about the particular example, that's weight is equals to 2, 3, 1 and x1, x2, x3. So we don't know what will be the weights. So what will be the bias? So in order to fit the parameters, we take some portion of the training data set. So in the previous example, a professor has chosen 70% for the training data set. Means we have used the 70% in order to fit the parameter. So means we train the neural network in order to fit the parameter, and the validation data set, we need to hyper tune the parameters. We need to use some optimization algorithm so that the hyperparameter should be tuned. And the test data set. So we already trained the data set, we validated the data set, but we don't know whether our result is right or wrong. So in order to test that one, some part of the data will be taken as the test data set. So this test data set is very important. It gives some accurate, this compares the given data set with the ANN values. Now we have some research objectives. So our main aim is to address all these research objectives, because the presentation, the international conference is based on artificial intelligence, application of artificial intelligence in the mathematical subject. So we know that the mathematical subject is that can be found in most of the real world application. We can define a mathematical problem for real world instances. For example, we can define the problem, heat transfer problem, using Fourier's law, Newton's law, or Stephen's law of cooling. And also for the COVID-19 problem, we may come across some mathematical model with respect to the COVID-19 problem, so which is the hot topic today. So I listed some 3 questions that will be helpful in order to discuss the physics informed neural network. The first one is, how can we address the heat transfer problem using effective AI model? So followed by this question, we have another one. So is there is any chance to include the physics governing laws into the predictive model? So finally, how can we address the heat transfer problem in view of artificial intelligence in upcoming years? So these are the research objective functions, research objectives. For the first question, I already enlisted some publications that published from 2020 to 2025, the last 5 years. So in these are the some main publications that concentrated on the heat transfer problem. For example, heat pipes, heat transfer through heat pipes, and heat pipe modeling, heat exchangers, thermal energy storage. All these applications uses AI techniques, basically machine learning, neural network, supervised learning, deep learning, and one of the paper that's published in 2024 that used physics informed machine learning. So this is the new emerging techniques that's introduced in maybe 2018 or 2019. So I'm not sure about the year. And they used some ensembling techniques like gradient techniques, deep reinforcement learning, and so many. So I just collected the last 5 years data. So now the question is whether this data driven technique, AI technique, is based on the physical laws, or whether this data driven methodology covers the physical laws. Obviously no, because the training happens solely on the data set. Whatever the data you give, the result will be obtained based on the data. That model will going to find the some hidden pattern, and corresponding results will be given. So undoubtedly we can say that the artificial neural network, which is dependent on the data, will not cover the governing physical laws. So that is one of the major drawback of the artificial neural network. So we can say it as a major drawback in the sense of physical laws. Then how can we address this one? So this can be addressed by using physics informed neural network. As the name suggests, we are going to infuse the physical laws along with the neural network, meaning we have some basic physical laws. Based upon the physical laws, we govern the equation, and that equation is directly combined with the neural network. So how to do that one? In order to implement the physical neural network, we don't need data. So this is the major difference. We don't need data as we need in the normal data driven artificial neural network. We want corresponding governing equation and the corresponding initial and boundary conditions and the suitable coding. So the basic artificial neural network we can done in the MATLAB code, but for the physics informed neural network, most of the researchers uses Python. That includes the libraries like TensorFlow, so that already has the inbuilt physical automatic differentiation coding. So moving to the procedure for solving the PD or ODE, so one can observe here that it is different from the normal traditional ANN concept. This procedure involves the following steps. First one, initialization, data collection, define collocation points, formulate the loss function, training, forward pass, and finally we have solution evaluation. So you may see here, initialization is nothing but defining the architecture. So what will be the input layer, what will be the output layer, and what is your defined problem. And data collection, so don't confuse with the data collection. Here the data collection refers to the independent variable or the boundary condition that's present in the given problem. And next we need to define the collocation points. So at that collocation points we are going to infuse the physical laws. So that's why the collocation points are important here. And formulate the loss function. So here loss function is nothing but residual or error. Usually we take mean squared error. The loss function is this one is a special loss function, so that I will be going to explain in the next slide. And the training, the neural network training will be done here. So next, the forward pass. After the training, the pin should perform the forward pass through the network. So this will this will test whether the solution is right or wrong. The last step is solution evaluation. In the solution evaluation, we check the accuracy. If the accuracy doesn't meet, we can again retrain the neural network. So what are the advantages of PIN? So the main advantages of PIN is it includes physical laws. So it underlies the physical laws, because simply giving the data doesn't cover the physical laws. Hence, doing the physics informed neural network, it incorporates the physical laws, and the data requirement here is very less. So for the ANN data, you need, for the ANN training, you need more data, but for the physics informed neural network, the data is very less required. So data means don't confuse. The data here is that the input data, the independent data. So that I will go into explain in the next slide. So generalization ability. So we can generalize with the limited data. And computational efficiency. Here the computational efficiency is mainly dependent on the defined problem. So if the problem is very complex, then we may get less error. So our main intention is to reduce the loss function. We have to get the minimal error. Suppose if the problem is very highly nonlinear, so we may face some computational inefficiency due to the nonlinearity of the problem. However, we can overcome this one by training the pin again and again and setting the number of iteration or number of approaches to the higher values. So now this is the main part here. So I have chosen one research paper. So that was published in the 2022. In this paper, I considered the heat transfer problem through the annular fin. I applied differential transfer method and modified residual power series method, which are the series problem, series solution. I got the result. So for the same problem, I'm going to apply the artificial neural network as well as the physics informed neural network, and we can discuss the difference there. So you observe the physical phenomena can be addressed in the form of differential equation or partial differential equation. So similarly, we have one physical occurrence, that is the heat transfer through fins. So fins are nothing but the extended surfaces attached to the primary surface that helps in heat transfer enhancement. You already know that the heat transfer occurs in 3 stages. I mean, the types of heat transfer: conduction, convection, and radiation. I considered all the mode of heat transfer for this problem. So this is the prime surface. This prime surface is attached with the annular fin. So TB is the base temperature and TA is the ambient temperature. The annular fin is having the thickness delta star. The inner radius of the tube or the primary surface is Ri. The outer radius is R0, and the radius of the annular fin is R. The heat transfer undergoes convection and radiation with the application of magnetic field. As of now, I neglect the magnetic field because I am mainly concentrating on the convection and radiation as well as the conduction problem. So let us consider the differential element of a fin, that is GR. The QR will be the heat entering into the element, and QR plus GR will be the heat coming out from the element. With all these assumptions, I'm going to define the differential equation, I mean the governing equation. Equation 1 is the governing equation that represents the phenomenon of heat transfer through the annular fin. So it includes conduction indicated by the first term and convection indicated by the second term, the radiation indicated by the third term. As of now, I neglect the remaining terms because I am talking only about the heat transfer process. Correspondingly, I have the governing equation given in equation number 2. So this one is the these are the non-dimensional terms used to convert the differential equation, dimensional differential equation, into non-dimensional form. So given in equation 4 with respect to the boundary condition, non-dimensional boundary condition equation 5. So beta is the thermal conductivity parameter, NCC is the convection conduction parameter, NRC is the radiation conduction parameter. So forget about the remaining one. So one can observe here that the problem is highly nonlinear because it involves the product of derivatives into the dependent variable, and it also have the product of theta dash into theta dash, derivative of the dependent variable. So this is the dimensionless form. Now I am going to solve this equation number 4 with respect to equation number 5 using any numerical method or analytical method, I mean semi-analytical method. So I obtain the data with respect to X or other thermal parameter. So here I considered the neural network architecture. This is the basic neural network architecture. So in this architecture, I have given input. This input is nothing but the thermal parameter values, beta values and NCC values. So this is the input. And what will be the output? Output is the heat transfer rate. In the equation 4, theta indicates the temperature distribution. So differentiation of theta with respect to X at the particular value 1, that gives heat transfer rate. So I collected the data by solving the equation and finding the derivative of theta with respect to X at X is equal to 0. So the heat transfer rate is considered as the target value or output value. So I constructed the architecture or design of the neural network with 10 hidden neurons in the hidden layers. So I trained using the activation function tan sigmoid and the linear function pure lin. I considered the error matrices. So these are the common matrices. So that's why we use all the professor also used the same matrices. So MSC, this is the mean squared error, R square. It is a coefficient of regression, and we can find the error rate between the RK45 values or ANN values. So what are the cases I considered here? The beta values varying from 0.5 to 0.55 or 0.52, any number of values, that is 1 or 2, and NC is varied from 1 to 2 or 1 to 1.1. These are the given input values, and the corresponding heat transfer rate I didn't mention here, but you should know that we are having here target data, that is heat transfer rate. So I trained the model. I received the output for 141 epochs. The mean squared error reaches the value of 3 into 10 power minus 10. So for the initial stage, the MSE is very high and it decreases as the number of approaches increases. Similarly, for the regression, R is equals to 1, R is equals to 1 indicates the data is trained very well. So this is the result. And error histogram, I consider the error histogram from training, validation, and test. This orange color line indicates the zero error line. So it is the nearer line to the zero. And this is very important. So you observe here NC, I consider the input NC and beta. So I obtained the ANN values. When I compare these values, ANN and the RK45 values, those values agrees excellently. The corresponding error we get here is of order 10 power minus 5. Similarly, for beta parameter, so I am getting the excellent value with the error value 10 power minus 5. So this is the numerical comparison. In the numerical comparison, I got the error when I compare the MRPSM results with the ANN results. So most likely I get it in the range 10 power minus 5, 10 power minus 5 to 10 power minus 6 to 10 power minus 5 for NC also, beta also. Now the question is that whether the ANN results underlies the physics governing laws. So it is obvious that these ANN results are mainly dependent on the given data, that is the input data NC and beta, and the output data, that is Q, the heat transfer rate. But in order to mitigate the limitation, I applied physics informed neural network. So for that, let us consider the governing differential equation and the boundary condition as equation number 1 and 2. Give the name RODE, RBC1 and RBC2. So X is the non-dimensional length. So I talked about the data collection, means data points or data collection. So data collection is nothing but giving the numerical value to X, whether X is from 0 to 1 or 0 to 2 or 0 to infinity, somewhat required for the your corresponding physical problem. So now let us find the residual or MSE of the given problem. That is equation number 1. So equation number 1 is subjected to the physics informed neural network by collocating the governing equation, and let us find the mean residual error. Mean squared error. Similarly, the boundary conditions, given boundary conditions should apply the physical laws. That should be collocated using the physical constraint given in equation 4 and 5. So the overall loss or overall residual of the system is given by accumulation of MSE ODE plus MSE of the BC condition, boundary condition, that's given in equation number 6. So let's define the architecture, neural network architecture given in this slide. So here Xi is the independent variable. So this independent variable Xi, I should give the Xi values. I am directly inputting the equation into the neural network model, and this theta, this is the dependent value. So this theta, I subject this theta to the automatic differentiation. So in the problem I have a second order differentiation, but in general there may be nth order differentiation. So I subject the given differential equation into the automatic differentiation. Similarly, the boundary condition is subjected to the automatic differentiation from the given equation, the Gourd equation. I can collocate the equation at some specific points, and I can get the MSE of the differential equation. Similarly, I can get the MSE, that is residual of the boundary condition or initial condition. These MSE contributes to the overall total loss. So now this will be sent forward pass to the neural network training. So finally, the iteration will be repeated until we reach some specified approaches and we got the accurate result. If the accurate result is not obtained, then we have to set the number of iterations more and we need to train again. So finally, if we got the minimal error, then the result is accurate. So here I intentionally compared the physics informed neural network with RK45. I mean Runge-Kutta-Fehlberg 4/5 order. So there is no need to compare the result with RK4/5 order. But in order to know the applicability of physics informed neural network, I solved the equation using RK4/5 method. I obtained the result, and I directly solved the physics informed neural network using the neural network architecture. I compared it, so one can observe that it is giving accurate result. So there may be error of order 10 power minus 3 or 10 power minus 4, whatever that we can see next. So now it's important to determine the loss. So during the training loss, we set the epochs to 300. So initially, when the epochs is very low, the MSC or the loss function is very high. And finally, when I set the epochs to 300, it receives almost, it's nearer to almost 0. So this is the very important aspects in the physics informed neural network, which is covering the physics laws as well as building the neural network system. So the physics informed neural network values are compared with the MRPSM. I have taken varying X values. X is nothing but length of the fin. Here I didn't compare the beta or NCC value because it's difficult to give the beta values and training again and again. So that's why I considered the varying non-dimensionless length of the fin, and I obtained the thermal profile, not the heat transfer rate, thermal profile. I compared the values. The error I got here is around 10 power minus 5 or 10 power minus 4, which is quite good. But in the artificial neural network, the data driven method, we got the error in the range 10 power minus 6 or 10 power minus 8. Sometimes it may take 10 power minus 9 to 10 power minus 11, but it failed to produce the physical behavior there. I mean, it failed to cover the physical behavior. Here, the physics informed neural network easily replicates the physical behavior hidden in the given equation. So there will be some advantages over artificial neural network. The main advantages is data efficiency. So we are not giving any data set here. By solving directly the problem, we can get the data and one shot solution, unlike the traditional method. So we cannot give the multiple forward or backward propagation and complex geometry handling. So we can say that by using FEM or FEM, we have to mesh the geometry. But in the pins, we are solving the problem along with the infusion of neural network. So that's why it can handle the complex geometry problems. So robustness to noise and analytical field production, it can provide the analytical fields to satisfy the governing equation by considering the total loss. And robustness to noise, it has a capable of delivering robust solutions with the limited collocation points. That's one of the major advantages of the physics informed neural network. So now I think I can conclude by stating the future ideas. So majorly, traditional artificial neural network is dependent on the data set. So whatever the data we give, the pattern will be analyzed by the model and the corresponding solution will be given. But in the physics informed neural network, it's based on the physical law of equations. I mean physical laws in the particular equation. So in the heat transfer through the annular fin, we have mainly 3 laws. First one is Fourier conduction law, Newton's law, and Stefan's law of equation. So all those will be covered by including the equation into the neural network. So that's why we can, as of now, we can claim that physics informed neural network is better than the artificial neural network. So combining the physics informed neural network with evolution algorithms like differential evolution algorithm or genetic algorithm or particle swarm optimization, artificial bee colony algorithms, the combination of these algorithms along with the pin can produce more optimized values with less minimal errors. And another one is we can use orthogonal polynomials during the collocating the points along with the physics informed neural network. So that can give the accurate result. So these are some of the references I have gone through, and so thank you. I hope you got some knowledge regarding the heat transfer and the application of physics informed neural network. So once again, thank you for the organizing committee and the supervisor for this wonderful opportunity. Now I am open to any questions. Thank you.
Any questions? Hello.
Yes.
आपल्याला काय करता येते ते
So I got one question. So what does a low and high MSE value indicate? So the low and highest value indicates that the MSE value is nothing but the mean squared error. That's the difference between the problem. I mean, if we consider the RK45 method, the data values and the ANN values, so there will be some differences. So the high MSE values indicates that there will be some differences between the RK45 values as well as the ANN values. However, the low MSE indicates that the model trained very well and it produces predictive accurate results. Yes. So another question: how can pins be used in scientific computing? Yeah, if we consider mainly the pin is based on solving the partial differential equation or ordinary differential equation. For example, advection convection equations or COVID-19 problems, and so many problems are available in the open literature. So one can apply the physics informed neural network based upon the physical governing phenomena. So we hope we can apply the physics informed neural network for basic differential equations. So then we can address the scientific computing also. So basically we want the governing equations or the physical equation representation of the physical phenomena.
Any questions?
So I have another one. How can pins be improved for better performance? So I already explained in the future ideas. We can include some optimization algorithms as well as the differential evaluation algorithms. So thereby we can include the pins application. I think I am done now. So over to Dr. Satish sir.
Yes, sir. I am very much thanks to Dr. Prasanna Kumar sir and Dr. As
Sorry, I can't hear you, sir.
Hello.
Yeah. Please,
Hello.
please. Yeah.
Yeah.
So
Yes, sir, yes. I am very much thankful to Dr. Prasanna Kumar sir and Dr. Varun Kumar sir.
Thank you. Thank you.
Yes, both deliver very nice and useful lectures in AI and machine learning. So this is very benefited to our researcher and newly research students. So on behalf of my college and behalf of my university's organizing committee, I am very much thanks to Dr. Varun Kumar and Dr. Prasad sir. So I take without my
Thank you, sir. Thank you. It's been a wonderful opportunity for me.
So I hand over to my Dr. S.S. Tiwade sir to introduce Dr. Nanda Kishore Chandan sir.
Hello. Good afternoon to all. It is my honor to introduce Professor Andakishore, yes, Chemistry, Siddharth College, Arts, Commerce and Science College, Mumbai. He has qualified SET, CSIR NET with JRF and also ARS, ICR NET and GATE exam. Sir has 23 years of teaching experience and 18 years experience in research. Beside research and teaching, he played important role in administration as a head, vice principal, IQAC coordinator, and NSS program officer. Sir contributed to the development of chemistry as a research guide.
Right, Shankar.
Sorry, sorry, sir. Network issue. Sir contributed to the development of chemistry as a research guide, member of Board of Studies in University of Mumbai as well as St. Xavier Autonomous College and Vivekanand College, Chembur. He has worked on many committees. He has completed 4 research projects. He has rewarded with several prestigious awards and fellowships. He was granted National Overseas Scholarship of 1.5 crore rupees by Ministry of Social Justice and Empowerment Government of India for studying at the University of Oxford, England. Has been honored with Mahatma Phule Ideal Teacher Award by Mupta Mumbai and Shiksha Ratna Puraskar by IF Society Delhi. Sir has authored 9 books and published 16 research papers in reputed journal. Sir also presented many papers in international conferences and has delivered invited talks as a research person, keynote speaker in different national and international conferences. Thank you. Uh, Carry on, sir.
Sir, can you give me the access for sharing my presentation? Make me co-host so I can share my presentation.
Okay, okay.
Co-host बनवा तर मला presentation share करता येईल.
Okay, sir. Okay.
4 minutes, sir. Chavan, sir.
Let me see. Is my presentation visible?
Sir, you are audible now.
Presentation visible आहे का?
Yes, sir. Yes. Yes, sir.
Presentation, my present. Okay.
It is visible.
Okay. My presentation visible. I'm audible. Perfect.
Yes, sir.
Yes, sir.
Okay. At the outset, let me congratulate the principal, management, head of the department of the Digambarrao Bindu Arts, Science, Commerce College, Bokar. And I'm very much thankful to this management and principal too for giving me an opportunity to be the part of this conference as a speaker. In fact, when I joined the last talk, on my screen, it was visible like physics informed neural network. So my talk is related to some neurodegenerative disorder, which is related to the neurons. So earlier talk was related to something AI and how it is linked with the mathematical equations. Mine talk is related to the chemistry, which is the brain chemistry, we can say. So whatever like disorders related to the neurons in terms of dementia type of diseases that I'm going to cover in my talk. So it's a synthesis of chitocephalin, which is anti-glutamate receptor for agent for the neurodegenerative disorders. So let me just comment on some diseases which are linked to this talk. As we know, nowadays, three diseases like dementia, which include Alzheimer, epilepsy, and Parkinson's, are very much common. What exactly is Alzheimer? Alzheimer is like memory loss. Like in India, normally we do consider peoples at the age of like 60 or 70, they are common to lose their memory. They forget the forgetfulness. We don't take it serious. But as we think about in a medical term or in terms of chemistry particularly, that there is something wrong, and that wrong thing is nothing but it's they are at the verge of dementia or Alzheimer type of disease. Now what exactly this Alzheimer is, like confusion, some point we confuse disturbances in short term memory, problems with attention and spatial orientation, so they sometimes cannot stand properly, personality changes, swing mode, unexpected mood swing, language difficulties while talking, they cannot talk properly. So all that diseases are related to Alzheimer. And as the statistics says that 7.4 of the adults at the age of 60 in India, they are suffering with this dementia type of diseases. 8.8 million to 55 million people, they are suffering across the globe with this dementia type of diseases. In India, only 8.8 million people are there who are like we do not focus more seriously. Those who have like culture, they go for the test and they go for the treatment, but most of the people they ignore. But in global perspective, peoples are very sharp, and they think about sort of diseases and they diagnose it and they go for the treatment. Now what exactly in Alzheimer's disease happen, the neurons, if you see the diagram, the first diagram, which is healthy neurons, and whereas the disease neurons, they are like scrambled or plaque found, black spot, and the neurons are not that healthy. So this is what the section, the cross section of the brain, where you will find how the neurons in the normal brains and the Alzheimer disease. Now what exactly this Alzheimer is the name of scientist or doctor who have invented this disease. At Germany, there was a patient at the age of 50. He died because of some diseases, diseases, and doctor was diagnosing her that something is wrong with the brain. And after the death, the doctor took the we can say the study of the brain, and he found that the neurons in the brain, they are something different geometry. And because of that, he come to the conclusion that the neurons, when they are having a plaque or the black spot or the defibration, or the fibrites are not in a proper connected, that particular sort of diseases related to the neurons, or leads to the dementia type of things. And this disease has been recognized after the name of the doctor. If you see the healthy neurons, you can see very perfect in the geometry. Whereas in case of Alzheimer diseases, you will find in the center there are some uh, spots and the amyloid plaque, which results that there is a deformation in the neurofibrillary tangles, and that leads to the loss of memory. There is another disease called as epilepsy. In routine language, we call fit or seizures. What exactly in epilepsy happens? There is a recurrent. That means the current is like our whole body works with the electrical currents. You know that sodium and potassium pump. They are the responsible for generation of the current, and because of that current, our whole moments, that signals will be given to their brain, and brain will read to that particular commands. So this is a simple electrical impulse, like in the house, when we switch on the button, the fan will work, or the AC will work, or the tube light will work. So that way we give the command and that particular object will work. In the body, exactly the same thing happens. Whenever the physical moment will give the command to the brain act accordingly. So that means the electrical impulse are the cause of the moment. So when the electrical impulse suddenly increases, that is we call as recurrent, then the brain stop working, because the some point that our instruments, when the electrical current increases, some point it get diffused, or the bulb will get diffused, or electrical TV or any instruments will make it may stop working. So in the same way, in our brain, when the current is not normally moving, there is a impulse or recurrent, then the brain stop working, and at that moment our body become uncontrolled, and we lost the awareness. So that everybody knows in the feet, people's when they get feet, they do not know what has happened. They become like a rigid body. So this particular thing is because of the neurons. Now go to the uh, another disease called as Parkinson's. Now this is a Parkinson disease, which is progressive neurological disorder, which results in the loss of dopamine productions in the brain. Dopamine is a dopamine secretion is a good chemical. Dopamine, like whenever you feel like whatever like take the example, you wanted to have that thing, like you want a Apple mobile, and suppose the day you got the Apple mobile, you feel very happy. So that day your brain releases excess of dopamine, that is called as happy chemicals. So the dopamine secretion when get reduced, or a change in productions, then there is a disorderness in the neuron transmissions, and that leads to the Parkinson's type of diseases, which includes again tremor, slow movement, and rigid muscles, impaired postures, balance, loss of automatic movements, speech changes, writing changes. That means everything is related to the central nervous system, and that central nervous system is controlled by neurons. If you see the normal sense and the Parkinson sense, you will find there is a less movement of the neurons. Now let's understand what exactly this neuro excitotoxicity. Now if you have a picture at the right hand side, there is a great gathering of the peoples, huge number of peoples gathers together, and suddenly something has happened which is dangerous to everyone. So everyone will run away with the ramponing. They damage, or they injure the nearby one. That means the peoples themselves try to protect each of them, and for the protections they harm to the others. So because of that sudden moment, there is a damage. That damage leads to some death or maybe the injury. So exactly the same thing happened in the brain. There are many neurons. When the neurons get automatically excited, so the moment will be huge, and because of the collision of the neurons on each other, there is a damage, or some point it may leads to the death. And that implicate the neurological disorder include stroke, Alzheimer, epilepsy, Parkinson's diseases, as well as traumatic brain injury. So that is we call as a brain hemorrhage some point. So all these are linking to the what? The movement of neurons. So if you control the movement of neuron, definitely all the solutions will be in one spot. So to control the neurons, what exactly the thing we have? We have the solutions, we have the some chemicals. So the today's talk is on the organic molecules, or we can call as a drugs molecule called as cytocephalin, acts as a glutamate receptor. Now the glutamate receptor means what? Receptor means like a person who is unknown to that city. If I wanted to go to Bhokar and I don't know about the college, and somebody from the Bhokar college will come to the station, and they will take me to the proper position. So somebody is taking me to the proper position, they are considered to be my receptor. So in the brain, there are some receptor. Like take the example, whenever in the body we take any medicine, the medicines is for headache, and we do put the medicine in the stomach. So how that stomach medicine will reach to the brain? So the point is, there are receptors. Whenever we put any drugs molecules into the biological system, the respective receptors will be activated, and they will take you through to the proper site. That is we call as receptor. Now the glutamate is one sort of chemical which is found in the muscles. There are some NADAP, that is AMPA, as well as kynic acid and glutamate. So all these are the receptor which recognize the cytocephalin, which is what? The anti-glutamate receptor. So what we are talking here, we are going to control the movement of the neurons. Who will going to control that? That will be controlled by the some buffer. Buffer means what? Buffer means like in terms of like titration chemistry, we do use acidic or basic buffer. So in that case, the acidic impurity or basic impurity can be balanced by the buffer. Or in normal way, when we are riding a bicycle, or maybe the car, or maybe the scooter, so scooter or bike or bicycle will have shock up. Shock up for what? Whenever there is a road shock, like if there is any pothole. So when your bike or vehicle go through that pothole, then you will get a shock. To balance the shock, it should not reach to your body. There is a shock up, and that shock up will not give you any sudden shock. So like that, the chemical called as cytocephalin acts as a buffer, and which control the movement of the neuron because it's an anti-glutamate receptor. Okay, so come to the molecule which is the interest of today. Now, this cytocephalin, if you look at, there are three different colors. That three different colors includes three different amino acids together: proline, alanine, and serine. Now, these three chemicals come together, get this molecule having the core 2 to 5 tri-substituted heterocyclic molecules, which is a core of that molecules. Now, the beauty of this molecule, that this molecule is found naturally, where in the fungus called as Eupenicillin seri PF1191. When we extract 10 kgs of this fungi, we get few milligrams of this drugs molecule. So the cost of this drugs molecule will be huge. So to get this molecule for the common people in a cheaper way, so we have to target this molecule in the laboratory, to synthesize in the laboratory, and to make it available chiefly to the public. So the target of my talk is to synthesis of cytocephalin, which is anti-glutamate receptor, or we can say uh, uh, particularly the buffer for the neuron safety. Now, what exactly this molecule is? This molecule is already synthesized by different scientists, different researchers. They have used a proline as a starting material and the carnaldehyde. And simply by coupling, they can easily synthesize these particular molecules. There is another molecule, there is another methodology from alpha hydroxymethyl glutamate, which on cyclizations can easily get the glutamate. And this particular scientists have used only two routes. And in my study, we have designated some different methodology to get this molecule synthesized. Now, if you see here, the well-known chemistry in the pericyclic uh, criteria or the class that is called as Claisen rearrangement, Ireland Claisen rearrangement, where we use the complex, which is a bimetallic complex for controlling the stereochemistry and as a quinine as a chiral catalyst. So in this process, the allelic group, which is considered to be ester of proline, which on treatment with the some basic stuff with the chiral catalyst, we can easily get 2-2 substitution across the pyrrolidine. So this particular stereochemistry, or we can say this, the geometry can be easily achieved with the help of this Claisen rearrangement. And this is very good chemistry where we can say the click chemistry that work very, very fast. So if you see the glutamate receptor, which on simple we can say the esterifications with the allyl alcohol, we can easily get allyl group, which is on treatment with the Claisen rearrangement, we can easily achieve the molecule 3A-B-C, and where the 2-2 substitution pattern can be easily achieved with a good yield, and followed by the esterification of the free hydroxyl group to ester. And then this particular ester, which on rearrangement treated with the Lawson's reagents for the conversion this oxygen to the thio compound, because thio is more nucleophilic for the substitution purpose, and alkyl halide called as malonate, alpha halomalonate, will be treated with the sulfur-based compound, and we can call this particular reaction is Ocean-Moser sulfide contraction. The sulfur will go off, and then there will be the condensation with the malonate. Now, this particular target molecule like 6A, B, C, D have a potential to get the chitocephalin synthesized, because the pattern of 2-5 substitution can be easily achieved. So this particular enamine type of compound, when on reduction, when we reduce it, we can easily achieve the target which is required for the synthesis of the chitocephalin. Now this reaction has been very much calibrated and work out for the further process. Now the stereochemistry of this molecule was perfectly matching to the molecule under study, which is chitocephalin, through annealing, that is we call as nuclear Warhauser effect. This is a technique where we can easily study this stereochemistry with the help of NMR spectroscopy. Now look at the application of this particular methodology. So our target was the synthesis of chitocephalin. If you see the molecule in the box, that if we target the red cuts, like amino group attached to the hydroxyl, particularly the carboxylic group. So when we cut it, or we can take that as a oxime, which on reduction we can get easily this particular amino group. That is the sort of part of your amino acids, and which on derivatization with the acylations or benzoylations with the aromatic ring. So that can be easily achieved. So the oxime will be the perfect match for the getting the one side of the molecules. Another side of the molecule can be easily achieved by cleavage of this molecule, and we can do this Fricker type of synthesis, and we can get easily this right hand side of this molecule too. So if we look at this retrosynthesis of these molecules, here the retrosynthesis have that particularly same geometry, where you will have a ketone to this side, which on oxidation will get this oxime, and followed by reduction you will get these molecules. To get this ketone, we have treated with the proper alkyl halide, followed by allelic rearrangement, and the starting material will be the L-pyroglutamic acid, which will be starting material. So in fact, the reactions will work like this. So reactions will be like which will be on esterification, on Claisen rearrangement, and then followed by the chemistry which is required to get the left and right can be achieved as a reduction, allylic hydroxylation, then cleavage of olefin to aldehyde and sticker synthesis. So that can be the ultimate aim or chemistry point of discussions. So we have the required molecule, the 9, for which is matching to the chitocephalin. So when we targeted this molecule to go for the oximation, because our oximation was the prime steps, so this 10 was targeted from 9. But what has happened, the characterization of the 10 was very difficult, because this 10 was very difficult in terms of getting the proper NMR, getting the proper mass spectra. NMR looks pretty good. Look at here. The NMR looks very clean, but the mass, which was not found correctly, 442, which is something different, which is funny structure, maybe like this or maybe like this, where there is a additional group is attached or some rearrangement type of stuff will be achieved. So we work on that molecules for a long time, but we did not characterize this oxime, because oxime was the key steps. Unless and until we cannot prove that oxime can be achieved, we cannot move further. So simultaneously doing that chemistry, we come across with one another paper where it has been like represented that nitrogen-nitrogen bond is possible if one nitrogen is oxime ether, another nitrogen is free, which can be converted to the nucleophile. And no doubt the oxime ether can give the electrophile nitrogen. One nitrogen is nucleophilic, another nitrogen is electrophilic. So nucleophile will attack on the electrophile, and there is a this reaction will collapse to form the nitrogen-nitrogen bond, and you will get this type of heterocyclic ring. So keeping in mind this this methodology, we design some simple chemistry. What simple chemistry is? Like diethyl malonate, when treated with the vinyl methyl ketone, a very simple chemical, on Michael additions with a simple base called as potassium carbonate in DCM. When we stir, we got a very clean yield of Michael adduct. And this Michael adduct was treated with oxime to get the oxime, that hydroxymethyl chloride. So which one uh, oximations gives you the clean oxime, which on derivatize with the dinitro derivative of aromatic ring. So particularly this will derivatize with the fluoro-2,4 dinitropenzene, where there is a simply derivation or protection of your oxime. So this is nothing but the protection. Now when we do the protections, so in fact this nitrogen oxygen bond is very weak, because this is a bulky group, and this nitrogen oxygen, whenever it come across with the nucleophilic stuff, they will break down and the ring may close. So we consider in a same way and treat it with the base to generate the nucleophile across the methine, which is active methylene compound. And when we treat it with the base in THF with the dry solvent, and in 1 hour, we got a clean absolute product of cyclizations. And this on reductions, we achieve the 2,5 tri-substituted pallidine cleanly. Now, this new methodology have potential to have a varieties of functionality across the 2, 2, and 5 positions. So we calibrated this methodology on different stuffs and different derivatives, and found the stereochemistry as well, and which was perfectly matching. So we did the varieties of the schemes to just calibrate this particular potential of these reactions, and we found a great results with a great yield. And we found this reaction is very much comfortable for going for the total synthesis of the molecules, which is our target. So we have tried another functionalities across the malonate. Like, as I told you, malonate was our target in this first 11 series. But malonate works very well. So we thought, let's try for the amido malonate. So one side there is a carboxylic group, another side there will be the amide group. And the Michael additions, oximations work perfectly. Even the oximeter was very much cleanly work. Whereas these reactions have a limitation that oxime ether have a potential to undergo for rearrangement, because oxime, the Beckmann rearrangement is always competitive reaction. So the Beckmann product was very clean, and we got a single crystals for Beckmann product as well. Whereas we got the cyclized product 50%, whereas 50% was a Beckmann rearrangement. And then we have monitored this type of chemistry, and we have reduced the formation of Beckmann product, whereas the cyclization product was maximum. And we got the great results for that system as well. Then we have tried for the nitro as well as cyanoacetate. So R1, when we took as a nitro or maybe the cyano, this particular methyl group, CH2, will be very much active for the further Michael addition and no doubt for the further reaction. So we tried in a similar way. The Michael additions work well, then oxidations, even formation of the derivative works very well. And in the last, when we try to get the cyclized product, because of the increase in the activity of the active methylene group across these alpha positions because of the NO2. Whenever there is a nitrogen across the nucleophile, so this nitrogen try to interfere in the rearrangement. The nitrogen itself undergo some sort of shifting of the electron instead of keeping the stable nucleophile, which should attack on the nitrogen of the oxime ether. So we work out all the stuff for nitro and cyano, but because of the extra stability, because of the nitro and cyano of that nucleophile, this particular chemistry did not work, and we end up with some sort of messy product. And we conclude that this type of substitution pattern cannot be achieved in this system. Whereas we come across with some different chemistry, different molecule which are impossible or very, very strained to synthesize, which can be easily synthesized with the help of this methodology. So we started the synthesizing the spiro as well as the antibrate compound, or maybe the cyclopropane, highly substituted cyclopropane ring synthesis by this methodology. So when we treated cyclohexenone in the similar fashion of the Michael addition with the diethyl malonate followed by the oximation and oxime ether. Oxime ether can be possible because of the tosylate as well as maybe the 2-fluorodinitrofluorine. But tosyl was also giving the good yield. So in a similar way, if you see here the bridge carbon having a double bond, which is impossible according to the Braid's rule. So it is against the Braid, so we call as anti-Braid's compound, which can be possible with this methodology. There is a competitive reactions for same, that is we call as Beckmann fragmentations. Instead of moving this nucleophile to the nitrogen, the alpha bond will break and there is a cyano group will be out, and this particular next alpha carbon will close to have a 3-member ring. So this particular chemistry got a high potential to get the 3-member cyclic ring, which is in a normal trend very, very tough to get. But through this chemistry, it is very easy. Another one, when the meldrimic acid was treated in a similar chemistry, we got here spiro compound, and the single crystal can easily understand the stereochemistry, the absolute stereochemistry of this spiro compound too. So these tough molecules which are having a different importance in terms of biological system was achieved by this methodology. But our target was to get the chitocephalin. So there was another unexpected results, which was the 6-member heterocyclic synthesis because of this particular chalcone and this cyanoethyl compound, which can be easily achieved up to the oxime. When we tried for the oxime ether, the oxime ether formation itself going to the formation of 2,3,4 compound, that is a 6-member heterocyclic compound, which becomes a new methodology for getting the 6-member heterocycle to be synthesized through this method. So for this 2,3,4, there is a single crystals and stereochemistry can be easily studied. With this methodology, we could achieve the molecules called as NP2530 to a natural product which have a potential antibiotic activity can be easily synthesized with the help of this particular molecules very quickly. The synthesis of this molecule can be achieved in a maybe the day or 2 days time, subjected how the chemistry will work out. At the most, in 2 to 3 days, we have finished the synthesis with the characterizations. So what exactly this chemistry here? We have to kept the one methyl group extra on the malonate, the that is methyl diethyl malonate, and uh, as usual, alpha beta unsaturated ketone on Michael additions, on oxygenations. What you will get? So first of all, we have to off the one carboxylate group by hydrolysis and treated with the base as well as heating. So that is we call as decarboxylations, followed by this ester, which will having the alpha proton, which are active when we treated this with the strong base. It definitely work out the chemistry called as cyclizations on particularly the protection of the oxime and leads to the formation of the cyclic compound, which on reductions we can easily get the 2 to 5 trisubstituted core of this NP25302 molecules. So our target was to get the synthesis of chitocephalin, and that was the ultimate target, that how to get this molecule, because it was failed in the earlier methodology. This methodology was perfect to get these molecules. Now what we have done in terms of retrosynthesis, if you see the chitocephalin, this molecules was very much perfect. Like if you take this OH and NH2 as a 2 to 6 as an olefin, so that can be 2 to 6 can be easily converted to the hydroxy methyl, that is amino hydroxylation. That is a simple chemistry. So 2 to 6 on hydroxy methylations, uh, uh, amino hydroxylations, we can easily achieve the chitocephalin. But how to get this 2 to 6? So 2 to 6 can be achieved by from the 2 to 263. What is 263? 263 is like an amino group here. And this should be the protected aldehyde. This protected aldehyde will be converted to the this olefin by simple Wittig chemistry, as well as reduction of this 263 will get this 266. How to get this 263? 263 can be easily achieved by 262. Now this 262 is perfectly matching with the chemistry which we have calibrated. So this calibration will be started with the L-aspartic acid. Now, if you see the chemistry over here, simple chemistry, the L-aspartic acid will be protected with the help of the uh, simple formaldehyde. When the formaldehyde will protected this heterocycle that is oxygen will be protected form of what? L-aspartic acid. Now this free acid can be converted into the allylic compound by simply uh, acid chlorinations. That is, when we treat it with the thionyl chloride or PCl5, this will be converted to the acid chloride, followed by the treatment with the organometallics can easily achieve this alpha beta unsaturated ketone. Now this alpha beta unsaturated ketone 238 on Michael additions can be achieved to get this 239. Now this 239 on oxygenations will be 240, which on derivations or tosylations will get 241, which is a perfect material for what getting the cyclized product. So this 241, when treated with a base, it easily cyclized to get the core of the molecules, which on reductions can easily achieve these molecules. Now this chitocephalin can be achieved very easily. We have calibrated this chemistry with the help of diethyl malonate. So to get the proper site, we are going to add a different active methylene compound called as the protected form of the aldehyde and the ketone. So this protected form of the aldehyde is N-methyl methoxy carbonyl compound. So this is a protected form of aldehyde when it is treated with again normal trend of the chemistry, what the oxygenations. Now we have this 239 where the one is the carboxylate, another one is the as a amide, but that is a protected aldehyde. Now this on oxygenations gives 240. This 240 on derivations, you will get the 241. Now this 241, when treated with a base, again, you will get cyclized compound. This cyclized compound on reductions, you will get perfect match. On hydrolysis, you will get the aldehyde. This aldehyde on treatment with the Wittig reagent will get this olefin, which on perfectly amino hydroxylation leads to the formation of chitocephalin. So this way, the synthesis of the chitocephalin is perfectly achieved with the help of this particular new methodology. So this methodology is having a perfect solution, because in the earlier case we had lots of problems uh, while getting the oxime out, whereas in case of this particular methodology, synthesis of the oxime is perfectly achieved, because here there is no chance to undergo the rearrangement, whereas in the earlier case there was a chance to undergo some point of rearrangement. And this particular chemistry, this particular natural product was synthesized, uh, tested with the different activities. It shows tremendous activity against the varieties of the bacteria. It was tested against the some neural activity, found great activity. And these molecules, particularly this chitocephalin, these molecules, is still on trial, because whenever any drugs molecules wanted to come in the market, it takes maybe the 10 to 15 years to come in the market, because it goes through the rigorous testing. And in Oxford, I did this work at Oxford University, and there they don't do the sync chemistry. Sync chemistry means whatever chemistry we do at the laboratory, we publish the paper, and what to do with that remaining chemicals or that synthesized chemicals, we simply throw into the sink. And that particular chemicals, these peoples, they test, they go for the market entrepreneurships. They each professors have their own spin out company, and whatever chemicals, whatever the applications they wanted to do, they make it as a product and they sell it out and they get the profit. And out of that, 60-40 ratio is there. The company, if getting 100 rupees, they have to pay 60 rupees to the university and 40 rupees to the professor. So each of the professor, they have their own spin out. But in India, we do focus only on academics. We do the sync chemistry. We think about the publication of the material. Slowly in future, so we may think about the spin out. Spin out means like take that molecules into the market for the some application based point of view. So this is all about the synthesis of the chitocephalin. I will take you through the some of the glimpse of the Oxford University. So if you see, this is the lab where I did this chemistry. This is a beautiful lab, most highly equipped, and ranking in terms of the facilities, number one in the world. If you Google out and just put Chemistry Research Laboratory, Southfield Road, Oxford, they will mention that this is the world's number one research laboratory. This lab was inaugurated in the year 2004, and I was very lucky to join that institute in the year 2007, just after the 3 years, and had a great experience and did lots of chemistry. Whatever I thought there, I put into the flask and I used to get results. So as a chemist, as a researcher, you have to be very uh, critical, or try to dare to do some out of the box idea. Like I am very happy to share with you the project which was given by my boss. The first one, the Alan Clayson, was given by Mark Maloney, but that did not work. So as a student, as a researcher, I did not stop. When that chemistry did not work, myself designed the second project. And when that project was like tested in the lab, I got all the results, all the spectra. It was very difficult to communicate to the boss. And then one fine day, I had a talk with the Mark, and he said, yes, your work is not going, but what to do? Then he said, you try some of the different methods, try this chemistry, try that chemistry. And all of a sudden, then I said, sir, can we proceed like click chemistry of like Michael adduct formation and followed by oxidation, which I explained to you. He said it might be difficult, but how come you will so confident? And then I showed him the mass spectra and then NMR and all the results. He was so happy and he admired me lots. And he said, "Okay, go ahead. You design your own project and go ahead with the chemistry." You cannot imagine, guys. In this highly equipped lab, I completed my PhD works in 2 years only. I had 4 years of time, but in 2 years I completed this chemistry, and I did lots of other chemistry as well. I designed number of projects. I work on that, and it was a great moment for me there. This was my group at Oxford, my supervisor, Mark Maloney. This is a very beautiful town called as Oxford, and Oxford University is nothing but the cluster of uh, 38 colleges. It's a cluster, and all the colleges, they are linked to the Oxford University, and each student have to be registered with the university as well as the part of the one of the college. So I was the part of the St. Peter College for the just admin purpose. Rest of the thing will be done by the university at that particular department. So this is the entrance of the Oxford, where you can see beautiful road where there is a church, and there are 38 beautiful colleges. Most of the Bollywood movies have been shoot over here for some, that great Harry Potter's was shoot in the Churchill College, which is this one. So this is city center of Oxford. This is one of the great museum, historical museum. This is an exam school of Oxford University, where the admin purpose student have to submit their thesis and rest of the thing. But so far in 4 years of time, I did not had been to that place, because everything is on your desk is so automated. You need not to rush here and there. So look at here. These are the two best pictures. The first one is Bodleian Library. The little boy, showing that this is a Bodleian Library having the greatest collections of the book in the world. Because British ruled each and every country. They collected books and materials, and the collection is all collected books are here. So the left hand side, there is a Indian house, where this house is designed there to rule the Indians by Britishers in the colonial period. So the Britishers were trained how to rule the India. So that's why it is named after the Indian house. This is some point a very tough winter at Oxford. Some of the glimpse of the London. This is London Abbey. That is the ministry. This is my friend. We're enjoying British food. Look at here some of the scholarships which are very important for the students as well as the faculty as well. If you see this National Overseas Scholarships sponsored by Ministry of Social Justice and Empowerment, which is sponsored by Government of India for full-time PhD program as well as postdoc as well as MS2. Nearly 100 scholarships will be sponsored every year. So those who are eligible or competent, they can apply for this. I am the recipient of this National Overseas Scholarship. There is a scholarship sponsored by Government of Maharashtra as well, that is called as Rajashree Shahu Maharaj. In collaboration with the Bharti and Rajashree Shahu Maharaj, that is Government of India, they have started the international scholarships. There is a Dr. Manmohan Singh scholarships for the Cambridge University. So most of the biochemists as well as biotechnology students, they will be prefer for the scholarships. Commonwealth scholarships even for UG teacher. That is any teacher who are on a UGC scale, they can go for these scholarships. And these scholarships will be for 6 months. And this is a great experience. When I had been to the Oxford, many Indian professors from the different universities and institutes used to visit, and that time I used to take care of them. So I had a very good time. I came across with many scientists and professors and vice chancellors. There is a scholarships from HRD Ministry, then Nehru Trust, Cambridge University, in the collaborations. Rhodes Scholarship, one of the best for Indian. Then Dr. Ambedkar Foundation Scholarship, Ministry of Welfare. UGC Scholarship for abroad. Then DST, then KC Mahindra, Fulbright scholarship for Indians and UK students. So there are many scholarships you can go through it, and those who willing to go for abroad for study, they can definitely try this, and definitely those who will fulfill their eligibility, they can get the chance for this. So let me thanks to my supervisor Mark Maloney, my institute, Siddharth College, then funding for my study at Oxford, the Ministry of Social Justice and Empowerment, Government of India, and not but the least, the college, Digamar Rao Bindu Arts, Science and Commerce College Management and Principal and Head of the Department. I'm very much thankful for giving an opportunity. Also, the Swami Vivekananda Tirth Marathwada University in Nanded for such a great conference on a great topic called as artificial intelligence, which is a need of today's. Though today we had a chemistry related to the brain, but the brain is required for the artificial that AI. AI will not work without that. So we need a brain, and then definitely all attendees, those who have participated for this conference. I'm thankful, and once again, heartily congratulate to the principal and head of the department. Thank you very much indeed. Yes, sir, I'm done. Yeah.
Hello.
Yes, sir.
Now I request all participants.
Yeah, if you have any doubt, please, I'll be happy to answer.
Yes. Now this session is open for discussion. Hello, sir.
Yeah.
I have one query regarding this Alzheimer networking.
Yes, sir.
Sir, what is the role of protein in formation of this Alzheimer amyloids? Is there is a way out for if you want protein structure or protein prediction method through this AI?
Actually, most of the time, you will find this is inheritance from the parents, and moreover, the lifestyle what we adopted. Like if you see in the foreign country, most of the people, like in America, most of the peoples are the sufferer of Alzheimer's, epilepsy, as well as the Parkinson's, because their lifestyle is different. So one of the factor is the lifestyle, and another one is it will be carried from parents to the offsprings. So that will be the another, and definitely it is related to the proteins, because whatever we have seen that fibroids, so they are the part of the proteins, and definitely some sort of disorder or some sort of deficiency of sort of proteins may lead to the plaque, and that is may the root cause, and that causes the excitotoxicity, which leads to the damage of the cells and leads to the dementia type of diseases.
So, is any protein marker, sir, on the basis of that we can diagnose or detect this Alzheimer formation?
In fact, there are some tests.
Okay.
Yeah, so we can go for the test.
But in that test, which markers, protein marker we are using?
Protein marker,
they are varying.
It's very difficult. It's very difficult for me to mention that mark, because I have not studied that point. Because my work was related to the drug synthesis. The biological synthesis is a different perspective.
Okay.
Yeah. Any more? Hope there is no any questions. Can we proceed further?
Okay, sir. We are happy with this
Thank you.
information. Yes, sir. Any other participant who have a query to sir regarding his topic?
Go ahead, sir.
Okay, any participant who is willing to present his work? Now with this, I must thank respected Dr. Chandan sir for his wonderful and thought-provoking session. As we know, due to current lifestyle, this Alzheimer is a very devastating disease. So we must work for it, or a sir's session will help us to work out with the help of AI and with the use of this chemical understanding of this Alzheimer. So thank you, sir. Thank you for this wonderful
Thank you very much. My pleasure.
presentation. Thank you, sir.
Thank you. Thank you.
All dignitaries and all participants, we are in valedictory. We are going to start valedictory function. Sir. So in this last phase of this wonderful international conference of valedictory function, I welcome all dignitaries and participants present over this online international conference. I request our respected Dr. Munde sir to grace this session as a chief guest. I request respected Punjab Chavan sir as a president of this valedictory function. Now, without taking much time, I request a BOS chairman, Honorable Dr. Munde sir, to guide us with his expertise in chemical science and convey his message over this international conference on mathematical and chemical science. I request Munde sir to please guide us.
Okay. Am I audible, sir?
Yes, sir.
Okay. Okay. At the outset, let me thank Principal Dr. Punjab Rao Chauhan sir, Digambar Bindu Mahavidyalay, Bokar, District Nanded, for organizing such a nice e-conference. And unfortunately, I couldn't hear professor from mathematics, but I heard, I listened total lecture from Nandakishore Chandan sir, who elaborated, who focused on the importance of that particular cytocephalin. And you know, all friends, that nowadays, because of this stress element, most of the people are suffering from the dangerous disease related to brain, and he explained the importance of synthesis of cytocephalin in the present scenario. He explained various methods and probably best method for the preparation of cytocephalin synthesis, and how it works on that particular three diseases which he mentioned. Nowadays, he also elaborated with figures that Indians are also suffering from these three dangerous diseases, and almost out of 55.5 million people across the world, almost 8.8 million people from India are suffering from the disease like Parkinson or Alzheimer disease and epilepsy disease. Uh, no doubt, friends, organization of conference is to make use of the present study for the betterment of common people. And Dr. Nandakishore Chandan sir worked on very, what you can say, applicable aspect, that is synthesis of cytocephalin, which is by this or that means used in the treatment of these diseases, that is glutamate receptor, and therefore it clearly gives us idea about the importance of working in the excellent laboratories like Oxford. He also told us that so many scholarships are available for our students, and obviously the aim or objective of any conference is to inspire the young talent of India to go for the excellent research in different institutes, and Oxford University, which is a cluster university having almost 38 colleges in the periphery, is the very good platform for all the young students to who are wishing to shape their future in the field of research. Uh, I am not going to elaborate the chemistry aspect which he discussed today, but I again hope that because of this particular organization, or because of this particular event hosted by the Boker College, will boost the morale of aspirants, all the aspirants in the near future, and they will get max benefit of this e-conference. Once again, without taking much of your time, because you have taken a lot of efforts to make this particular academic event fruitful, uh, I again congratulate the organizers, Jadhav sir, then SB Chavan sir, Principal Panjabrao Chavan sir, and all the management who directly or indirectly helped with the uh, mm, professor and principal of the college to host this event. I again, uh, once again, I congratulate all the members, and I will stop here. Okay, okay, Jadhav sir.
Yes, thank you, sir.
Mm.
Uh, as a chief guest remark, sir has guided us and he is continuously guiding to our staff and student. He has highlighted aims and objective of this conference, how it is applicable and useful and significant in not only academic and research, but also he has highlighted in real life situations. Now, he is eagerly always trying for, or he is putting its effort for benefits of student. So thank you, sir, for your
Thank you.
guidance and consistent support to our institution. Now, with this, I request and I am welcome Professor, respected Professor Dr. Santosh Devsarkar, sir, as a president of this program, president of this valedictory function of International Conference on Mathematical and Chemical Sciences. With the help of AI, we are focusing this conference. So, without taking much time, I request Professor Dr. Santosh Devsarkar, sir, uh, for his presidential address. Thank you, sir. Am I audible?
Yes. Yes, sir. You are audible and visible.
At the outset, I would like to congratulate the principal of college, Professor Dr. Chavan sir, and both the organizing departments, mathematics and chemistry department, Dr. Satish Chavan sir and Jadhav sir. I congratulate both of you and both the department for organizing such an academic event. It was an international conference on use of artificial intelligence in mathematical and chemical sciences. And you have invited very renowned persons, eminent scientists who are working in this area from last almost 20 years. So for the successful organization of international conference, once again, I congratulate all the team members, management and principal of the college. Thank you.
Thank you, sir. Professor Dr. Santosh Devsarkar sir has concluded his presidential remark. He has highlighted the need of topic artificial intelligence in research, and though he is a professor having a very huge uh, chemical science research experience, he has pointed out the resource persons engaged in this conference were highly educated and experienced. So definitely, sir, their session, their guidance, their research will going to be helpful for participation and our also faculty members who have joined over this conference. So thank you, sir, for your consistency and this presidential address guidance. So with this, I would like to invite, or we are in the last phase of this conference and this valedictory function also. So I invite Mr. P.V. Take sir, propose vote of thanks.
Thank you, sir. We are in the concluding phase of the International Conference on Artificial Intelligence in Mathematical and Chemical Sciences, ICAIMCS 2025. I am very much thankful to Dr. Shailendra Devlankar sir, Directorate of Higher Education, for accepting our invitation as the inaugurator of this conference. I am also thankful to the chief guest of inaugural function, Honorable Vice Chancellor of Swami Ramanand Tirth Marathwada University, Dr. Manohar Chaskar sir. He always encourages our novel activities. I am also thankful to the President of Valedictory Function, our beloved Principal, Dr. Punjab Chauhan sir, for presiding over the inaugural ceremony. I also extend my heartfelt gratitude towards the keynote speaker, Dr. Prasanna Kumara BC, for sharing his valuable views on the topic predicative machine learning technique for performance analysis of earth air heat exchanger. In the technical session first, we have heard Dr. K.S. Varun Kumar. I am thankful to him for enlightening us for predictive analysis of heat transfer phenomena using physics informed neural networks, a comprehensive study. In the second session of this conference, Dr. Nandakishore Chandan shared his views and expert opinions on the topic synthesis of catecholine, a potential anti-glutamate receptor therapeutic for neurodegenerative disorders. I am thankful to him for accepting our invitation and sparing time for us. And in the valedictory function, the chief guest, Dr. B.R. Munde sir spared time for us. I am thankful to him on the behalf of the organizing committee, and the Dr. Santosh Devsarkar sir, who accepted our invitation and presided over the valedictory function. I am also thankful to him. And I am also very much thankful to all the delegates who presented papers and submitted papers for publication. The organizing committee, the convener, Dr. S.V. Chauhan sir, Dr. G.D. Kotapalle sir, Dr. Madhav Hegde, and Sachin Tivde. I am also thankful to the anchor, Dr. Venkatesh Jadhav, all the participants, research scholars, and students. Without their participation, it would not have been a successful event. Last but not least, I have no words to express all my feelings. Only thanks and thanks and thanks. Thank you very much.
Thank you, sir. In very brief, he has thanks everyone. Now, with this, we have a small announcement from organizer that those who have interested in presentation, we are taking their presentation, and with this we can say this valedictory session is ends here with the permission from chief organizer and organizer team. So once again, thank you to every delegate and participant to joining this international event. So thank you everyone. Hello. Now, I request Chetan Visave to present his work. Hello.
Hello, sir, am I
Chetana
audible?
Visave. Hello, madam. You
Hello.
are audible.
Yes, sir. Let me present my screen. Thank you for your opportunity. Is it visible, sir? Can you see my screen?
You are visible and audible too. Just start
Okay,
your
sir. Thank you.
presentation.
Thank you. First of all, good afternoon to all. And I would like to thank all the organization for giving me this opportunity. Myself, Chetna Visave, and currently working under the guidance of Dr. Rajendra Devre, University of Mumbai, Department of Mathematics. So today I'm going to give contributory talk on Hamiltonian and Eulerian nature of power graph of some finite groups. So the concept of directed power graph of group was introduced by Kelarov and Quinn in 2000 as the digraph whose vertices are elements of G and any two vertices A and B are adjacent in directed power graph of G if and only if B is expressible as integral power of A. Further, Chakraborty defined an undirected power graph of a group as graph PG with a vertex at G and two distinct vertices x and y are adjacent if and only if there exists some positive integer k such that one of them is expressible as integral power of another. Then we have some preliminaries. In 2030, Abbajam made a survey about power graphs in which they provided some results about Eulerian and Hamiltonian nature of power graph, which are listed below. So let G be a finite group which is not of prime order, and if maximum of omega G, where omega G is set of all order elements of G, if it is prime, then power graph of G is not two connected. Another one is let G be a finite P group, then the undirected power graph of a group has a Hamiltonian cycle if and only if order of G is not equal to 2 and G is cyclic. Let P be an odd prime, then undirected power graph of P group is true connected if and only if it is Hamiltonian. For a finite group Zn, the power graph of Zn is Hamiltonian for all values of n greater or equal to 3. Let G be a finite group, then the undirected power graph Pg is Eulerian if and only if order of G is odd. Then there are some basic definitions which we require throughout the study. Eulerian cycle is a cycle which visits every edge of a graph exactly once, and a graph which contains Eulerian cycle is said to be Eulerian graph. Then Hamiltonian cycle is a cycle which visits every vertex of a graph exactly one, and on the similar line, Hamiltonian graph is a graph which contains Hamiltonian cycle. Then we have a concept of two connected graph. A graph G is called two connected if for every vertex belongs to vertex set of G, G minus X is connected. In other words, a graph with vertex connectivity 2 is said to be two connected. So we have obtained some result throughout our studies. So first result is let G is equal to UN be a finite group. Then the power graph of UN for values of n to be power of prime and 2 times power of prime is Hamiltonian for all p greater than 3 and for p equal to 3 and k greater equal to 2. Then if G is equal to UN is finite group, then power graph of UN is not Eulerian for all values of n greater than 2. Then we have obtained results for symmetry group and alternating group also regarding Eulerian and Hamiltonian nature. Sorry. So let Sn be a symmetric group of degree n, then the power graph of Sn is neither Hamiltonian nor Eulerian for all prime values of n where p is odd prime. And moreover, power graph of Sn is not Eulerian for all n greater or equal to 3. Another one is let An be an alternating group of degree n consisting of all even permutations from Sn. Then we have following results. Power graph of An is both Hamiltonian and Eulerian for n equal to 3. Power graph of n is neither Hamiltonian nor Eulerian for n lies between 3 and 16 and for all odd prime values of n greater than 3. Moreover, power graph of n is not Eulerian for all n greater than 3. Then this is a particular result if G is a finite group which is not of prime order and if maximum of omega G is prime where omega G is set of all element orders of G, then power graph of G is not Hamiltonian. Then for a quaternion group also we have obtained the result. Power graph of quaternion group and also power graph of Lyons-4 group is non-Hamiltonian and non-Eulerian. In general, power graph of dicyclic group is non-Eulerian for n greater equal to 2. Then if we have G as Zp1 raised to n1 cross Zp2 raised to n2 cross Zpn raised to nk, which is a direct product of finite cyclic groups, then power graph of G is Eulerian if and only if all pi's are odd primes. Let G be a finite cyclic P group where P is an odd prime, then power graph of a group G is both Eulerian and Hamiltonian. In particular, power graph of Z P raised to M is both Eulerian and Hamiltonian for all primes P greater than 2. Then if G is a finite group of order PQ, where P and Q are distinct primes, then power graph of G is Hamiltonian if and only if G is cyclic. And moreover, power graph of G is Eulerian if and only both P and Q are odd primes. Similarly, we have obtained the result for a abelian group G with order as PQR, product of 3 distinct primes. Then power graph of G is Hamiltonian. Moreover, it is Eulerian if and only if each of the primes PQR is odd. So we can conclude our work as we have discussed an Eulerian and Hamiltonian nature for the power graph of following groups: UN, SN, AN, Q2 Lyons-4 group, ZP raised to M, product of ZP1 raised to N1, P2 raised to N2, PK raised to NK, finite group G of order PQ, and finite abelian group G of order PQR. These are our references. Thank you.
Thank you, madam, for this very short and wonderful presentation.
Thank you,
Any
sir.
participant? Now this presentation, our presentation is for open for discussion. Any participant, you can ask question or you can put your question in chat box also.
Sir, see if any other participant wishes to present.
Any other participant who is willing to present?
Yes, sir. Yes, sir. I'm from chemical side, chemistry. Hello. Hello. Hello.
Yes, madam, you are audible.
Yes, sir.
So, yes, madam, I welcome you all, you and please continue your presentation. I request Dr. Manisha to present his work. Yes, madam.
Okay. Good afternoon, everyone.
Yes, madam. You
Myself,
are audible.
Dr. Manisha Diltode, from Department of Chemistry, Assistant Professor, Guru Nanak College of Science, Ballarpur. My presentation topic it is the newly synthesized polymer from phthalic acid, ethylene diamide, and sulfuraldehyde. Something went wrong, sir, because this slide not changing. In this presentation, I will cover the introduction, synthesis method of PA-EDF terpolymer, thermostories, result and discussion, and conclusion. And next one, what is the terpolymer or polymer? What is the polymer? It is the number of monomers joined together to form the high molecular weight compound. The weight of that polymer it is the greater than the 1000. 10,000 molecular weight होता है इसका greater, and the terpolymer it is made up from the monomer and it is the low molecular weight compound and it is used as a starting material. In this presentation, I am using the three different monomers, that is the phthalic acid, ethylene diamide, and sulfuraldehyde. This is the terpolymer. For example, A plus B plus C. It is the all the three different monomers to join together to form the polymer. Here are the some examples of the PVC pipe, polyethylene bottles. These all are the polymers. And here it is the synthetic method which are synthesized by the three different monomers. When we take in the phthalic acid, ethylene diamide, and sulfuraldehyde in the three different in the ratio of the 1:2 in presence of acid as a catalyst. Here I use the glacial acetic acid and the reaction mixture was heated at the 140 degrees Celsius up to 6 hours. After the reaction period was completed, the resinous solid brown color product was obtained and this is the structure. Here we are calculating the thermogrametric analysis, thermal data we are calculating by using the two different methods, that is the Freeman-Carroll method and Sharp-Penput method. And what is the advantage of this Freeman-Carroll method? So it is the time and temperature parameters can be changed, can be varied simultaneously, and one can obtain the order of reaction and the activation energy in the single experiment by using the Freeman-Carroll method. These all are the equations we are using for the calculating the activation energy, order of reaction by using the Freeman-Carroll and the Sharp-Penput method. This is the thermogram plot, TJDT plot, that is the thermogrametric analysis plot and the differential thermal analysis plot to find out the decomposition of the particular synthesized terpolymer. Here are the three different decomposition peaks are obtained in the range of the 1000 to 225, in the range of the 300 to 555 degrees Celsius, and the 555 to 674 degrees Celsius. There is the three different decomposition peaks are obtained, and out of these three decomposition peaks, there will be two peaks will be supported by the DTA because we get the two exothermic peak which is supported to the thermogrametric analysis. The first decomposition temperature obtained in the range of the 100 degrees Celsius to 255 degrees Celsius. This first decomposition due to the loss of the two water molecule which is entrapped with the polymer, and the calculated value of the loss of the mass, it is the 9.37, which is the correlate with the value obtained from the graph, that is the 9.51. And the second decomposition curve, which is obtained, that is the in the temperature range, that is the 300 degrees Celsius to 554 degrees Celsius. This is due to the loss of the 2 COH group, which is attached to the phthalic acid, and this CH2 unit, which is attached to the benzene ring, side chain attached to the aromatic nucleus, and the partial degradation. And this degradation will give the percent mass loss of the will be 83.84 for the calculated value, and which will be nearly close to the found value, will be very close to the calculated value. And this also supported by the exothermic broad peak, which is obtained in the TGA curve. This is the supportive curve which is obtained in the that temperature range, and also third decomposition temperature, which is obtained from the 555 to 674 degrees Celsius, that is the complete degradation of the molecule, and the observed calculated value, it is the 100% degradation of the polymer, and the found value from the graph, it is the 99.42%. And also here we get the very broad peak, that is the exothermic peak, which is the supported to the TGA data. Next one, from this thermal data, we have to calculate the by using this Freeman-Carroll method and the Sharp-and-Punch method, we have to find out the activation energy of the synthesized polymer. The activation energy obtained from the both the method, which is the nearly same, which is the closely related to each other. And the next data will be obtained, that will be entropy change. We have to calculate by using this Freeman-Carroll method, free energy change, frequency factor, order of reaction. We will get the entropy change. It is the negative value of entropy change. From this, we conclude that our synthesized product is the more order structure compared to the reactor. And the very low frequency factor value conclude that the decomposition reaction is very slow. There will be no any plausible reason for the with low value of the frequency factor. And the order of reaction, it is the 0.98. The thermal degradation curve of this terpolymer I have shown in the figure. There will be shown the 3 stages of decomposition. From the decomposition started from the temperature 22 674 degrees Celsius. At this 674 degrees Celsius, the complete degradation of polymer. The first stage of decomposition, which shows the slow range of the 100 to 225, correspond already I discussed in the from the graph. The second stage, due to the loss of the 2 COH group, CH2 side chain attached to aromatic ring, and the partial degradation of the benzene ring, and the calculated value, which will match with the found value. And the third degree of decomposition, which is started from the 555 degrees Celsius up to the 674. After that 674, there will be no change in the loss of the mass. Because of there will be complete degradation of the terpolymer resin. And this is the activation plot of the terpolymer by using the Sharp-and-Punch and the Freeman-Carroll method. Here, the decomposition reaction is taking place in the temperature range 100 to 674 degrees Celsius. In case of terpolymer resin, there will be 2 stages of decomposition after loss of water molecule, which is also supported by the DTA curve, 2 exothermic DTA curve obtained in the peak, and the activation energy calculated from the Sharp-and-Punch, because we are using the 2 different methods, and the Freeman-Carroll method, which is the good agreement with each other. Thank you. Hello. Hello.
Yes, madam. Thank you for this your research-oriented presentation. I request any participant for a discussion. Can I ask one question here, ma'am? Meanwhile, the next participant is requested to be ready. Hello, ma'am.
Hello.
Yes, madam. How we can use artificial intelligence in this, your research?
Artificial intelligence, actually, it is the reaction is a very time-taking reaction. Nowadays, this work already I done in the year of the 2012, and nowadays I am using the microwave assisted reaction. Means it is the time-saving reaction. I hope this work is also applicable for the artificial intelligence will be also applicable for this work.
Okay, madam. Okay, thank you
Thank you, sir.
for this very hopeful and interesting discussion. Now, is any participant willing to present?
Shall I present, sir? Rahul Deshmukh from mathematics.
Yes, sir. You are welcome.
Yeah, okay. Thank you, sir.
So, I welcome Dr. Rahul Deshmukh, sir, to present his
Sorry,
work.
sir. It's Mr. Rahul Deshmukh.
Okay, sir.
Somebody is already
You will be
sharing,
soon,
sir.
doctor. Good luck.
Yeah, yeah. Okay. Thank you, sir. Sir, somebody is already sharing that. Did not stop.
Yes, yes.
Previous
Yes.
one.
Sir, Teyala. I request the technical person to share Deshmukh sir's screen. Technical person, please share the Deshmukh sir's screen. Rahul Deshmukh sir's screen.
Yeah.
Sir, you are co-host now. You can share from your device.
Yes, sir. Sir, is it visible?
Yes, sir. Your screen is now shared.
Okay. Thank you, sir.
Yes, sir. Now, please open your presentation.
Yes. My topic is graph-based decision-making method using soft set relation. I'm doing research under Sayed Jalil, sir.
Yes, sir.
This is my outline of my research papers. I will go with further. I'm using for this abstract for this research paper. In this, we will use this novel approach to analyze and evaluation of complicated choice of issues by utilizing the graph representations of soft set relations in our choice making methods. This is the new research era where soft sets relations can be designed in the form of that some graphical format. By looking at the incoming and outgoing values of choices inside the graph-based framework, suggested one more algorithm, and we have converted that algorithm into part of Python program, which will be currently analyze the very short optimal solutions. And our task is to extend this works for the general approach as a general algorithm for a big data sets with the help of Python library packages. This is the very short introductory matters. Just I will take only one part. That is soft set theory was introduced by Mondoso, provides a framework for dealing with uncertainties and imprecise data, where data is not available in crisp formats, it is available with some parameter format. And that data can be applicable to handle by different ways. These are some specific definitions are expected in my work. So this is soft set definitions. Order pair Sx is referred to an soft set over U, where S is a function which is from X to power set of U. So we can say U is a parameterized collection of subsets of universal set U. So definitely in mathematical idea, it is not a crisp sets where its binary relations can be designed. The soft subsets, we have to follow that properties of existing set theory can be extended for soft subsets, and with the help of properties can be analyzed. We are also expected about extensions part of that Cartesian product of two soft sets, so that we can define some relation as a subsets of this Cartesian product, and we can form some relative results. Another point is expecting about the basic results of graph 3, because I'm using the graph 3 approach for solving some problems. Just I've taken that problem for tourism in my district. So that's why I'm using some basic concepts from graph theory. So this is brief idea about how we have to represent your general soft sets in the form of some parameters. So if we choose, suppose something set, suppose X is having suppose some parameters as brilliant, average, and healthy. and we have to define some soft sets with respect to these parameters. And there are some students having a choice for x1, x2, x6 with this choice of brilliant, average, and healthy. And then we'll form some relation with respect to choice of students, which is mentioned by that these parameters. And we can form with respect to these results as a tabular representations with some definitions is called as adjacency matrix, or we can say in the terms of ijth entry for storing data. Because whenever we want to store some results in the computer data, we should work with either in the tabular form or either in the form of say in the computerized array format storage location. So I'm using some of these parameters with respect to brilliance, average, and healthy, and these are the students list having x1, x2, x3, which satisfies some of the results having some relations I am defining. Suppose if I defining U is a universal set and X is some parameter sets where E1 stands for brilliant, E2 stands for average, and E3 stands for healthy. The subsets can be defined as with respect to S of E1 satisfying some students having these results of the brilliant students, say as X1, X2, and X5. Similarly, for S of E2 and S of E3, we can categorize these subsets with these specific parameters. Now our task is to obtain some subsets as a relation with respect to this Cartesian product of two sets, and I can form some relation with respect to subsets as a counterexample for my graphical representations, and I can form these new relations, and I can represent one more relations in the form of a graph theory, because graph theory having with some different approach, and I'm using the technique of a directed graph, where some directions I have mentioned here from S of E1 to S of E1, that will be the self loop, and whereas S of E1, S of E2, S of E3, or S of EI are represented as the actually elements from that vertices, and the corresponding directed edge indicates there is a something relation that I can be formed with respect to S of E1 with respect to S of E1. Actually, this directions is not by both ways, but I have formed with only left to right direction, so it will be incoming and outgoing edges. Then I'm using some algorithm to analyze these problems and to handle these problems to obtain an optimal solution for that a decision-making problem. In the form of, say, we can say, if we're defining some universal set with respect to, suppose I'm taking these problems from Sindhu district and nearer to Goa district, Goa state, because I have taken some beaches and I want to analyze what should be the best solution for that a good beach or specific beach I can choose with the help of some choice of some different parameters. So I'm using some parameter sets with respect to attractiveness of factors, and now I'm designing some steps. I'm using some techniques for incoming and outgoing path. Path is a distance. Path is a traversing distance from that one vertex to other vertex, and we can count the number of incoming path as well as outgoing path for that graph-related results. Again, we require to convert this point into the vector representations in the form of binary format, either 1, 0, or something, so that we can indicate outgoing edges and incoming edges in this format. Then our task is to adjust this incoming and outgoing edges for each vector by using some attractiveness parameters, which parameters we are following from that our universal set U with respect to that relations. And we will follow the result with respect to computing the total number of outgoing or incoming edges. Now, again, we are using the optimal B solutions. In might be some of these solutions can be categorized in the form of, say, tie-break options. So in that case, we will take a choice for a suitable method. Now, I'm just using one my problem to analyze this entirely algorithm. So I have taken U is a set of that beaches where I have taken Tarkarli beach or Alibag beach, Ganpatipue, Bhogwe, Sagreshwar, or some Baga beach from some regions from Konkan regions, Raigad, Ratnagiri, Sindhudurga, and Goa. And I have taken some parameters as beautiful, clean, lonely, smooth, sandy, and breezy beach. These are the some classifications of soft sets over that these parameters which covers that elements. Now I can convert these problems with the help of soft subsets as a relation. Now I am designing that my relations, whatever I am choosing, that subset one is the relations with respect to choice of that users, and I have categorized as these results with respect to a directed graph. With respect to these are indicates S of E1 with respect to S of E3. So this is incoming edge for S of E1, and there are 3 outgoing edges from S of E1. Now I have converted these problems with respect to how many incoming edges for each vertex and how many outgoing edges for, or how many paths for each vertex. So I have converted that problem into 1, 3 as a parameter, 3, 1, or 1, 3, 2, 2, or 3, 1. So we can go for further as a case. This is 1 incoming edge and 3 outgoing edges. So I can go with further for using this. Now I am converting this my parameters, which parameters with respect to beaches is covered, that I have shifted from binary notations of vertex to vectors with respect to these beaches, with respect to these parameters. Now, I am using one technique to identify the which parameter you find out that is about the incoming for 1 and outgoing for 3 that I have added in my this parameter for incoming and outgoing vectors, so I can generate these tables for incoming and this for outgoing. Now my task is to find out some of these first all elements for beaches B1 or B2, B3, B4, B5, B6. So 4 plus 2 plus 2 plus 4, I will take this column sum of these vectors and I can generate these results as with respect to these total incoming and outgoing values for B1, B2, B3, B4, B5, B6 are 12, 12, 5, 7, 11, 13, 11, 7, 8, 10, and 8, 4. And we will get the optimal solutions. That is the best solution for my problem is with respect to decision-making problem is a Tarkali which having incoming with respect to maximum ages. I can ship these problems as a calculation with respect to Python program. I'm using some part of as a packages, and I have designed this my same program for these problems. It's a program for current problem. I have to generalize for the generalized case. Now, when we analyze all these things, we will get the solution for same thing in the form of vectors and analyzing. So whenever we have a very big data sets, we can extend our data sets as a part of elements and we can get the results. So I'm just coming back for conclusion. So we have provided a method for program for analyzing soft set relations in this work by creating a decision-making method based on graph representations of this interaction. So either with respect to incoming or outgoing edges. The above summarized algorithms offers methodological way to choose the best option based on the soft set relations. And by using this graph analysis, we can calculate incoming and outgoing values, which is the attractive options for that problem. I would like to extend my work in this my problems with future work as to increase the algorithm efficiency and scalability across a wide range of industries. Future work may be involving it to the handler bigger data, having big data sets that will be applicable to work with the help of some artificial intelligence factors or some machine learning factors, which will be the evaluate the big data solutions, and that will get the superior solutions to analyze any decision-making problems in any type of system. So these are the references I'm using for my papers. Yeah, thank you, sir. This is from my side.
Thank you, sir. Thank you, Mr. Deshmukh, sir, for this
Thank you, sir.
wonderful presentation.
Okay.
Now I request any other participant who is interested to present. Organizers, is anyone interested? Hello, everyone. On the behalf of Chief Organizer, convener, co-convener of this International Conference on Artificial Intelligence in Mathematical and Chemical Sciences 2025, which is organized by Digambara Bindu College, Bhokar, in collaboration with Swami Ramananda Tirth Marathoda University, Nanded. So, with this all wonderful technical session and very interactive session from dignitaries. And I also congratulate all the participants who have presented their work in this on the occasion of this international conference. So I thanks everyone from organizers, conveners, and every team member of organizing this event. So thank you one and all. Thank you everyone. With the permission of chief organizer and organizer, here we are concluding this session and as well as conference. So thank you one and all, and hope we are meeting in upcoming events. We will continue this research journey in upcoming days. So thank you one and all. Thank you.